Hello everyone, may I start?
I'm sorry, Ivan, there is still opening on another track and we are not ready to start, sorry.
Okay, let me know please.
I'm sorry.
Let me know when I can start please.
Yes, of course. If you want, you may join another track and then come back if you want to listen to the introduction and to the opening of the event.
Hello everyone for track B. Is anybody here from the chairs who are responsible for the track? Or there are only presenters here?
I guess there are no chairs, so, but Ivan is already ready. Maybe we can.
Okay, so I will be responsible for this track. My name is Dmitry Ignatov. I'm the proceedings chair, but I'm also involved in the organization. So, hello everyone, and we would like to start with the first talk on gradient-based adversarial attacks on categorical sequence models via traversing an embedded world. And if the presenter here, I believe this is Ivan Fursov, we can start. So,
Hello, everyone. Can you hear me?
yes, I can.
Super. So my name is Ivan. Today I'm going to present you gradient-based serial attacks on categorical sequence models via traversing an embedding world paper. But first, we need to discuss what is an adversarial attack. Adversarial examples are input to machine learning models that are designed to fool the model. This is a well-known topic in computer vision. However, generating coherent adversarial examples in NLP and other discrete sequences is a challenging task due to discrete nature of data. First of all, it's hard to add imperceptible noise, and then it's hard to learn the transfer function directly via backpropagation, as in computer vision. The current state in NLP and other sequential data fields is limited. First of all, existing algorithms depend on heuristics. They are constrained to NLP usage only, and there is no proper metric to evaluate the effectiveness of attacks. In our research, we aim to develop an algorithm that generates natural-looking sequential adversarial examples and apply these algorithms to areas such as spam detection, fraud detection in backend transactions, recommendation systems, and control generation of texts. We developed an algorithm which is universal, can work both for NLP and non-NLP domains. Then it produces semantically correct examples, adversarial examples, and it's reusable with no need to retrain it for new data sets. The theory and algorithms behind our research are the following. We focus on black box attacks via the substitute model training, and we focus on non-targeted attacks, meaning that what we would like to do is to change the model prediction to any class except for the original one. And major components of the proposed solution are sequence-to-sequence model, which we use to generate adversarial examples, and a deep Levenshtein model, which is used as an approximation of eddy distance. We propose the following schema for adversarial attacks. First, what we need to do is to pre-train a masked sequence-to-sequence model. How it works? We have a sequence, we mask it by removing, replacing, or inserting some tokens. Then using an encoder, we encode the sequence into a hidden representation, and then ask a decoder to reconstruct the original sequence. Then, using this pre-trained sequence-to-sequence model that learned how to reconstruct sequence, we use it to produce adversarial attacks. The first step is to encode an arbitrary sequence into a hidden representation Z. Then we apply some slight alterations to the hidden state and reconstruct the sequence from this new hidden representation and obtain an adversarial example. But how to obtain and update this hidden representation? The first approach is to use Monte Carlo, which we proposed in our research. The intuition behind Monte Carlo updates are the following. We would like to step into the direction where adversarial examples lie. So how to do it? We sample from normal distribution, and then we add this sampled vector to the hidden representation and do an update with the probability alpha, which depends on the probability of the targeted class and on the distance between two sequences. For distance, we took word error rate. So the lower the probability of the targeted class becomes, the higher the probability of a step. And the lower the distance between two sequences, the higher the probability of a step. We repeat this iteration many times and obtain an adversarial example by decoding a new hidden representation using our decoder. And as for the naive implementation, we actually can step into the random direction without any probabilities and hope to find an adversarial example. So this is the first approach. We also propose Cascada, categorical sequence continuous adversarial attack. This is an end-to-end approach, fully differentiable, and it consists of two models on top of what we discussed. First is a deep Levenshtein model, which is a differentiable approximation of error rate. We train it in the following way. We have a pre-trained encoder from sequence-to-sequence model. For any sequences x and y, we obtain vectors zx and zy, and then we can calculate the approximated word error rate. The higher the rate, the more dissimilar sequences become. Also, what we need to do is to train a substitute classifier also on hidden representations. And then using this formula, we can directly optimize that by minimizing this formula. So you see here is a substitute classifier that outputs probabilities, and here is a deep Lewinstein model that outputs word error rate. This approach allows us to faster find new adversarial examples by using only one update of the hidden state instead of many. As for the experiments, we use 3 data sets. One is from NLP. It's a text classification task. Then we have a fraud detection in electronic healthcare records, and we have a gender prediction in banking transactions data. We target different models. In our research, we have RNN, CNN, and simple baseline of logistic regression. We attack these models. Then we calculate many metrics. The first is, which we propose to use, is normalized accuracy drop. We calculate how many examples are misclassified and normalize it by the distance between the regional sequence and the adversarial sequence. Also, we just look at how many misclassified adversarial examples there are, and we look at perplexity, which stands for, by looking at this metric, we can understand how natural our examples look. So on the slides, you can see main results. We compare ourselves with the current state-of-the-art model called HotFlip. It's a gradient-based method to flip tokens and replace them with adversarial ones. We see that our approach, Monte Carlo, shows good results on 2 data sets, and our approaches generate more coherent adversarial examples if we look at perplexity metric. On this slide, you can see examples of adversarial attacks we produce. Here are examples of HotFlip algorithm, and here's an example of SCADA attacks. What is important here is that our approach is able to generate semantically correct adversarial examples. It is because we use a sequence-to-sequence model that is trained to do so. On the other hand, HotFlip tends to corrupt semantic meaning of the sentence and insert the same tokens regardless of the context of the sequence. In this case, sequence is just a text. So, in conclusion, what we proposed in our paper is a direct optimization of eddy distance between adversarial and original sequences. Then we proposed fast end-to-end approach without the need to introduce any heuristics for the data. Then our approach is universal. We can apply it for NLP and non-NLP domains. And the proposed solution produce semantically correct adversarial sequences. That's all. Thank you all for coming. if you have any questions, please don't hesitate to ask.
Ivan, thank you very much for the presentation. Now it's time for questions. If any, please. It seems that there are no questions yet or so far. So let me ask one more question as a representative of AIST program co-chairs board. So you mentioned that your sequences are discrete, but did you use some techniques like frequent sequence mining to find the patterns or build classifiers on them just for comparison purposes? Maybe your adversarial approach can be also addressed in such a way. I mean, frequent sequence mining from data mining domain. Can we use them here somehow?
Thank you for your question. Actually, we did not try this, but probably this is a good idea. However, what we need to understand is how to use this model when we would like to optimize the when we would like to directly optimize adversarial examples, because if we transform the original sequence into some continuous form, how to use this model, to change some words or characters in the original text using this new model. This is a question, but anyway, thank you.
Thank you for your answer. Yeah, I think it's really a challenging task if we would like to use such techniques. They are of combinatorial nature. But I think that putting these techniques on adversarial schemes, it's quite interesting as well. So thank you very much.
Thank you.
If we have no more questions, do we have some? It seems no. We can go to the next speaker. Let's thank Ivan again. Thank you very much.
Thank you all.
The next speaker, according to the schedule, is either Dmitry Medvedev or Alexander Diakonov. And the talk is on new properties of the data distillation method when working with tabular data. It's quite intriguing as well, since the distillation techniques are of increasing popularity.
Okay, so hello, my name is Dmitry Medvedev, and my paper is about new properties of the data distillation method when working with tabular data. When we try to distill data, we try to reduce its volume to train our models faster while achieving the same quality. In our work, we try to explore properties of tabular data distillation and answer the question, is it possible to use once obtained synthetic data to train models with different architectures? So, on this slide, dataset distillation problem formulated as an optimization problem. Let theta 0 be the initial model's weights, vector sampled from a fixed distribution P. X be the original data, and tilde x be the synthetic data. at with tilde b a synthetic learning rate, L small b a loss function, and here we try to minimize the error when model trained on distilled data tries to predict original data. The model is indicated by theta indexed by j and n is the total number of iterations of training model on distilled data. Here we can see the training on distilled data. Index G corresponds to the inner model index because we need few models for better estimation of gradient. And initial weights of inner models sampled from a fixed distribution. We need this for a better generalization of distilled data when training models with various initial states. And S is the number of internal steps of one internal epoch. Note that minimization goes with respect to distilled data and synthetic learning rates. We also can call them synthetic data and synthetic learning rates. As you can see, to do only one gradient step of this optimization problem, we need to first to do n gradient descent steps to train a randomly initialized model with distilled data and learning rate. Thus, the method has high time complexity, and also another problem is that it has high memory complexity due to the fact that at each optimization step, we have to store n copies of the model. Due to high time and memory complexity, in the case of visual datasets, where we use big models and big amounts of data, we can only do extreme distillation. Previous works report cases of leaving only, for example, 10 examples per class, which reduces the size of the dataset by 600 times. Tabular data allows us to explore less extreme cases. In our paper, we distill data for a simple two-dimensional binary classification problem. Here we show the data distribution for this problem. And we can use, to solve this problem, small neural networks as classifiers. For example, linear neural network, 2 layers or 4 layers models. The architectures are shown on this slide too. Plots on this slide demonstrate the convergence of training procedure on original and distilled data. Y-axis corresponds to logarithmic loss, and x-axis corresponds to the number of done optimization steps. Different colors correspond to the different architectures. Here also shown the boundaries of the 95% confidence intervals estimated by several restarts of data distillation procedures and training procedures on the original data. Note that convergence in the case of original data takes from 2 to 4,000 steps. And the whole training on distilled data takes just 200 steps. This number, 200 steps, was chosen by us and fixed as hyperparameter of the distillation procedure. In our case, the training procedure takes 5 epochs with 40 steps each. Fixed number of states means that there is a risk that models may not converge, and increasing training time may require restarting of the entire distillation procedure. The volume of the original data is about 1,000 objects, and the volume of distilled data is only 320 synthetic objects. This number is also chosen as hyperparameter. For each of already mentioned 40 steps, we have a batch of 8 synthetic samples. It's important to mention that the distillation procedure takes around 480,000 passes through a neural network. As a result, the total distillation time for all 3 architectures and 10 restarts reaches 4 hours, while usual training procedure of model on the whole original data lasts only a few minutes. Because of such high time complexity, it makes sense to sample the data only once and use it for faster training of many models with different architectures to achieve almost the original quality. To explore such possibility, we produced an experiment demonstrated on this slide. This table shows the result. Here we can see the mean, accuracy, and its standard deviation, which is estimated by 10 restarts. Columns of this table correspond to the architectures of trained models, and rows correspond to architectures of models that participated in distillation. Here, the first row corresponds to the original dataset, and others for a linear model, two-layer model, four-layer model. So diagonal represents results when we train data on the same architecture as we distill data. Note that the quality of the linear and two-layer architectures trained on distilled data is higher than when trained on the original data. Plots on this slide show the boundaries of the decision rules also. For median quality models trained on the original and distilled data. Here we have two-layer models, original and distilled data, and four layers model, original and distilled data. The progress of two-layer architecture is clear. Using distilled data, models can build more complex decision rules, which bring them closer to bigger models. Note also that the quality of the four-layer models had decreased. And problems arise when we try to train a model of one architecture on data distilled with the model of different architecture. For example, in this row, in this column, we have a very poor result for four-layer model, which was trained on two layers, on data distilled with two layers architecture. It's also interesting to analyze the distilled data. In this slide, the plots visualize the data distilled for a different step, numbers, and the different architectures. The first row contains data distilled for linear model, the second row for two-layer model, and the last is for four-layer model. Distilled data is indicated by star points with different colors. Blue is for one class and red for another, for positive and negative classes. And also the original dataset is indicated by small circles. As was mentioned earlier, for each step, we have only 8 samples, 4 samples for each class. Here we can see that distilled samples for the linear model are located near the decision boundary, here and here. As we suspect, this can cause poor generalization when training different architectures. On the other hand, samples of two layers and four layers architectures don't seem to have such a problem. In addition, distilled samples look somehow similar of these models, and therefore it's strange that we have such low accuracy in previous table in the case of training four layers models on data distilled for two layers models. We think that such problem can be caused not only by distilled data. Synthetic learning rate also can be a reason. Here we show synthetic learning rates for our models. Note that there are strong fluctuations from iteration to iteration. So it seems difficult to just replace such a complex scheme with an universal one. Nevertheless, we show that a standard strategy, which can be found on the last plot, can improve the quality of model trained on distilled data. This strategy increases step sizes in 1.1 times at the beginning of each new epoch. For for some time, and then similarly decrease them in 0.95 times. This strategy allows us both to remove synthetic learning rates and to increase training time. Now, if you can see here, we now can train on 2000 steps instead of 200 steps. This slide shows improvement brought by using this strategy of longer training with undistilled learning rates. For ease of comparison, the upper table shows previous results and the lower shows new. And as we can see, the problem of training 4-layer model on 2-layer models distilled data has gone. And also we can see that the quality for a few other cases increased too. So the natural assumption is that data distillation using all three architectures can lead to better results. To do so, we instead of using 3 internal models, if we will return to the beginning, internal models were used for better estimation of gradient, and they had the same architectures. Now we will use different architectures and look at the results. So to do so, we use these 3 architectures and use 1-layer, 2-layer, and 4-layers models. Here we can see the results without a strategy of using usual learning rates, not synthetic. And the last column shows us if we will train longer without distilled learning rates. We see some improvement in quality of 2-layer model and 4-layer model. So thank you for attention. Any questions?
Thank you, Dmitry, for your talk. And now it's time for questions. I believe that the listeners can ask questions using their mic button in Zoom interface. So please ask Dmitry if you would like to ask him something on the work. It seems that the audience is slightly shy to ask questions. Let me ask maybe a provocative question. And distillation is quite popular for neural networks with non-tabular data, with complex data, I would say. But here, the example you studied, it's rather illustration that distillation can be of some help for tabular data. And you took those 2 moons, the well-known data set for clustering. It's also in scikit-learn, in where data commonly freely available. But what is the added value of your research for the community? So,
Okay,
what are the key lessons for us?
Okay. The letterbox, as I mentioned, when they try to distill data for visual data sets, they use highly extreme cases of distilling data because this algorithm is really has really strong time constraints and memory constraints. So the results of these papers were just closer to answer some theoretical questions of is it possible to reduce data and to train on it. But we tried to investigate generalization problem, and for this, for some results, we needed less extreme cases. For example, not just 10 classes per example and just one gradient descent step of of training on distilled data, but for example, 160 examples per class and 200 steps of final optimization. And also this brings some positive side, because when we train on visual datasets with such extreme constraints, we couldn't achieve the quality, the good quality on, for example, CFAR 100 or CFAR 100 on models not even with different architectures, but with different initializations. So here we show that if we use less extreme distillation, we can achieve some good quality. Also, when we train longer and use not synthetic learning rates, just some common scheme.
Thank you for your answer. When I looked at your slides and the pictures where different distillated data sets regions were shown, I was thinking about SVM, the well-known technique for non-linearly separable cases, for non-linearly separable cases, and it seems that in that respect your approach is somehow similar, that distillation can capture the borders in non-linear fashion. So I like this point as well. So thank you very much for your work.
Thank you. Thank you for questions.
It also brings some insights to those who would like to use distillation techniques for tabular data, that's for sure. Thank you. Let's thank speaker again, and we move on the next talk on human action recognition for boxing training simulator. The work is prepared by Anton Brailovsky and Ilya Makarov, and I believe that Anton is the main presenter here. We are slightly ahead of schedule, so is Anton here?
Yes, I'm here. Do you hear me well?
Yeah, can you share your screen?
Yeah, of course. Let me. Do you see something? Is it clear?
Yeah, I can see clearly your screen. Hope the others as well.
Can I start?
Yes, please. We are slightly ahead of time, but I believe that those who would like to be here, they are already here. So start slightly earlier. Yes, please.
I think the same. Okay. Hello and good morning, everyone. My name is Anton, and today I'll introduce you a paper named Human Action Recognition for Boxing Training Simulator, written by me and Ilya Makarov. This presentation will be split on the following parts. And first of all, we are going to talk about the problem that we solve. And next, we will talk about the dataset that we created during this work. After, we will have a glimpse on the different models we used. And finally, we will discuss the results and make a conclusion. Modern technologies allows you to improve the quality of the training and achieve the better results. Recently, computer vision technologies have started to find an application in some sports to control the quality of the training. For example, in boxing, one of the most useful applications of computer vision technologies is to recognize and correct the boxer's punches during the training. This will allow the boxer to progress independently without having to hire a trainer. So the main goals of this network is to, is to create a neural network solution for recognizing boxing hits on a continuous video. And also, due to the fact that there is almost no suitable data in this area, we set the second goal to create a data set containing records with examples of various punches. And now I want you to discuss with me our data sets that we created. We choose 5 the most popular punches that we also able to recognize. First one is here, is named punch, is a direct hit with a far hand. Second one is a cross. It's a side kick with also far hand. Then is an uppercut. It's a low hit with a far hand. Last hit is a jab. It's a direct hit with a near hand. And finally, it's not a hit, it's just a defense. It's a locked hands or a long pause without hits. Eventually, we collected a data set contains more than 1,000 different hits with average length of 40 frames. And also, we collected 4 different types of data. It's a video, it's a mask, it's a depth, and pause. Every video in the dataset contains one human that randomly and continuously punches. Here you can see an examples of frames from the dataset. There are 3 different people on the different backgrounds and different clothes hits. And in total, we collected almost 30,000 of frames with actions. And before we start training our network, we cropped the background of the image and the shape our frames to the square with size 224 pixels. And also, in order to create more stable solution, we augmented our data during the training. We did color augmentations, mirroring of the image, and zooming and detailing of pictures. And right now, let's have a look on the models, on the pipeline that we used to solve this task. To solve the task of action recognition, we introduce a pipeline with 3 stages. On the first one, we delete all images that do not contain actions. On the second stage, we find the boundaries of the image of the actions in untrimmed video. And on the last stage, we predict a class for each action in found boundaries. In order to find the frames without actions, we use a simple AIST model that solves a binary classification task. So for each frame from given set, we predict whether it's contain action or not. For the action classification, we use a little bit complicated model named SlowFast. The main idea of this network is to use 2 different frame rates, and on the top pathway we use only several frames from the set, while on the bottom we use every frame. In our case, on the top we use every third frame. Next, after these two frames goes through the network, each frame goes independently to the network, but these two networks chain in parallel and spreading information to each other after each block. At the end, we have a probability to the class of this particular frame set. And also, in the original slow fast paper, they use 3D convolutions. And in our work, we try to avoid them because 3D convolutions have a huge number of parameters and it's really hard to train them. We try to use spatial temporal convolutions instead. For the action localization, we also use slow fast based model, but we change the head of this model. In the case of localization, the model predicts two vectors of probabilities. First vector is a probability that the current frame contains a starting point, and the second vector is a probability that the current frame contains the ending point of the action. And after, we use a preprocessing to transform the probabilities into boundaries. And the post-processing contains the three steps. First of all, we binarize the given probabilities by the threshold that we found on the validation data. After, we calculate a midpoints per each probability, or per each probability, and finally, the action boundary is a middle point between two closest end and start points. Also, we try to reduce the length of our pipeline, and we try to combine a localization and classification tasks together. And the first, our approach is a mask network. Here we also use a slow fast approach, but in the end we try to predict the class of every frame in this set. And the second approach is action localization and classification network. Here we try to not predict a class, but a long vector where the first number is a number of action in the given set. The second n values is the length of each action, and the second part, it's a probability for each found action. Now it's time to have a glimpse on the results. In the first task, we will discuss the model that found non-action frames. Here we use two ResNet model. First one with the 3D convolutions, and the second one is with spatial temporal convolutions. And we can see that a few 2D convolutions train faster and show the better results than the model with 3D convolutions. Analyzing the result, we must say that the most error for this network occurs at the junctions of the classes, because it's really hard to recognize whether the boxer is preparing a new hit or just staying and waiting. In the classification task, we use much more models. Also, we add here the well-known IHD model for action classification also. And we can see that this model trains faster than other models, but show not significantly, but less quality than the slow fast approach with spatial temporal convolutions. Also, we must say that here the model makes error with uppercut class, because sometimes uppercut really frames with uppercut really close to defense due to the hands position. For action localization task, I must say before we start to analyze the results, that the output of action localization network is a vector with zeros everywhere except the boundaries of the classes. So we assume that the prediction is true positive if the distance between the target boundary and predicted boundary less than or equal than some number d, where d is changed from 3 to 5. So here we can see the F1 score for different distance between true and predicted labels. Also, the prediction is false positive is the distance between predicted point and true value is more than d, and also false labels count as false negative if this prediction was missed by the network completely. Here we also can see that our approach with slow fast shows the best results, but also we tried here to train the approach based on our based on the model that was trained for classification task, and after we changed the head of the network and tried to continuous fitting it, its train time is really low, but also the quality of this network is also not so good. In the end, we tried to use our full pipeline for prediction in untrimmed video, and we found that the accuracy dropped not significantly, and the most sensitive action to boundaries is the cross, because the quality of the cross is dropped more than the quality of other actions. And also we can notice that the total length of the video is twice or a third time longer than the prediction time. So we can conclude that the pipeline is able to work in almost real time. Okay, it's time to sum up all the results. And now we can say that we develop a strong pipeline with three steps that allows us to solve the task with good accuracy. And moreover, we collected a huge data set with more than 1,000 actions of 5 different types of punches. In future work, we plan to create a much more representative data set. We will plan to add new actions, more people and location. And also, it's really a good idea to combine this whole pipeline to one-way model. And also, we will try to predict not only the actions, but predict the quality of each punch. And also, if you're wondering how the network works, you can go by this link and look and have a look on the video. I don't know if I have a time, I can show it for you, but if not, you can find the presentation and look it by yourself. And thank you for your attention. For me, it's all. I will be happy to answer on your questions.
Thank you very much for your talk, Anton. And now it's time for questions from our listeners and maybe the other speakers who are also the listeners as well.
Yeah, of course.
Do we have any questions? Please welcome. Don't be shy. You can conceal your video, but you can only speak. Okay, it seems that questions can come from me again. Your work has an applied flavor, I would say, and of extreme importance is the data set that you collected, prepared. Is it freely available at the moment on GitHub or somewhere else?
Yes, it is. In the work, you can find a link on the dataset, on fully dataset, and also all code of this network is available on GitHub. It's also, I didn't add it in presentation, but in my work, you can find the links on the.
You know that even if Springer is somehow proprietary body for access in terms of accessing papers, you can publish your work at archive with a proper acknowledgement of Springer's original contribution. So thus you can facilitate further promotion of your work, and the other authors can download it, can find your data set, and so on and so forth. They probably have another opportunity to publish data sets with a permanent digital object identifier. Unfortunately, for this year of AIST, we did not have time for experimentation to propose it to our authors. But since we do post proceedings, we may ask them about this option, and most likely all the authors, if we manage to obtain it, will be informed and have a chance to share their data with Springer, but you need to carefully read those conditions, the terms. Okay, one more question, since we have time, is about your competitors or rivals on the market or in terms of models. Do you have them or not? Maybe there are already boxing simulators.
Yes, the funny thing that after I did this work, the group of also, I think, Russian guys develop a huge site for UFC. They develop a huge model that also can recognize punches, can recognize much more punches as me. They develop a system that's able to, do a 3D post-processing. They can add some promotions while the video, but it happens after I did my work. So I wasn't able to read carefully through their models during my work. But of course, in the future, I will maybe also will talk to these guys because I think they are Russians also.
Yeah, so that's nice. If you have a paper, you can confirm that your work is somehow solid and you presented it at scientific conference. So it might be an argument for collaboration, further comparison. Okay, I like this line of work where we have a possible real outcome of a demand in industry. So thank you, Anton, once again. And we can go to the next talk if the presenter is here and ready. I believe that the next presenter, if, according to the schedule, is Evgeny Burnaev. But it's not 11, it's not 25 past 11, so we can make a short 5-6 minutes break until Evgeny is here. Okay.
Hi, everybody.
Hello, Evgeny.
Yeah, so according to schedule, it was 11:25, so that is why I was.
We
Okay,
are ahead of
so
time.
let me share the slides. Unfortunately, I was giving a talk at some other workshop.
Oh.
That is why I.
Sorry for that. You can have 3 minutes more
Yeah.
for
Okay.
preparation.
So here is it.
Don't worry.
Second. Okay. So do you see the slides, guys?
Yeah, I can clearly see it.
Okay, good. So I'm going to discuss how we can apply Bayesian filtering for prediction of time series data depending on external variables. Actually, banking performance, it depends significantly on the macroeconomic situation, and this situation is characterized by various external indicators. For example, here you can observe how the ruble interbank rates depends on time, and around 2000 end of 2015 when we had a crisis, so we observed that ruble interbank rates increased significantly. And at the same time, if we observe, and this is how currency interbank rates depends on time. And by these vertical lines, we denote moments of significant deposit churn. So we see that the banking performance, which of course depends significantly on deposits and their churn, this in turn depends significantly on the external macroeconomic indicator. It's quite obvious. And the question is how we can construct a model which connects some internal banking indicators with external macroeconomic parameters. So in this talk, I'm going to discuss this problem for net revenue from acquiring. We'll consider the prediction of this net revenue from acquiring with respect to vintage. In our case, vintage is economic units grouped by some categorical characteristics and united by a specific time interval. Because in case of acquiring, these are different acquiring contracts corresponding to some group of banks and signed at some specific time period. And so we'd like to forecast the value of the vintage or the sum with respect to some vintages. In the considered problem, we have 48 groups. Each group is characterized by a specific segment, territory, affiliation of a client, and the vintage is composed with respect to a starting month of a contract. So, and we forecast for each group total revenue for 12 months ahead, depending on the macroeconomic indicators for this 12-month period. So of course you may ask, okay, why do we need this? Because in practice we don't know macroeconomic indicators 12 months ahead, but this is about macroeconomic modeling. So some macroeconomic expert tells us which macroeconomic indicators he thinks will be in the next 12 months. And so based on these indicators, we would like to predict this complex data, how our revenue from acquiring evolves in time. This is an example how revenue for a single vintage depends on time. So you see that the time series has some complex behavior. This is another. This is how total revenue on a group level behaves on time. So again, the behavior is complex, and the main difficulty in this problem is that we have more than 7,000 different time series corresponding to different vintages. And we would like to predict each of these time series ahead, 12 months ahead, depending on the current macroeconomic situation for these 12 months. And at the same time, the problem is that the length of historical realization is very small. So we have like 4 or 5 years or so of historical data, and the dimensionality is very high. However, these time series are very dependent due to territorial proximity and or similar businesses of the corresponding banks. And so we'd like to construct a latent space so that if time series are closed in a latent space, they then they have similar predictions and similar behavior, and the prediction must be different for distant latent points. And so mathematically, we can formalize this as follows. We assume a Markov structure of the model. So for each moment of time t, we have a specific section of time series values, and we have values of control variables. In our case, control variables are defined by the macroeconomic variables. And so the assumptions are as follows. We can find a representation Z of smaller dimension such that the evolution of Z can be represented by a simple Markovian dynamics. That dynamics is almost linear. That is, this is a standard Kalman filter, except that here we have nonlinear dependence of the matrix A and matrix B on the latent variable Z itself. And the observations x sub t are given as a nonlinear reconstruction from these latent variables. So actually, this is a kind of neural network generalization of the standard Kalman filter. And as neural networks here, we use standard fully connected neural networks. So that means that we construct a universal mapping from X to Y, where and this universal mapping is given by the following formula. This is a linear combination of neuron activations A0, A1, and A2, and each A0, A1, and A2, and A3 are given as some nonlinear function, some nonlinear transformation of linear combination of input variables. So this is the standard two-layer perceptron, and we are going to use fully connected networks of this type, but maybe not with two layers, but maybe with 3 or 4 layers in our model. And in order to train the model, we impose a probabilistic structure on it. So the idea is as follows. We assume that the observations x sub t are given as a nonlinear transformation of low dimensional latent variables plus noise. Noise, we assume that the function f is given by a simple neural network. So it is a linear combination of neurons as in this slide. So this is a linear combination of such functions g. And plus some constant plus noise. Here noise is assumed to be Gaussian. The initial value for the latent variable is also modeled by a Gaussian distribution. And then we have a nonlinear dynamics in the latent space, where the noise is also Gaussian, and representations for the matrix A, B, and this remaining term O, they are given also by fully connected neural network. So if we represent the matrix A as a vector, then this vector is modeled by a linear combination of outputs of the fully connected neural network. The same is for B and for O. Moreover, we assume that parameters of the internal layers inside the neural network, they are shared. Here we have only only parameters of the last layer of the neural network, they are different for different functions A, B, and O. So what we want, we have a trajectory of size t, and we would like to estimate parameters of this model. We need to estimate parameters WA, WB, WO. These are parameters of these matrix functions. And also we need to estimate parameters of the corresponding hidden layers of fully connected neural networks. And of course, to construct the prediction for each time series values x, we also need to estimate its latent representation z. For that, we are going to use the posterior distribution over z given the realization of the time series x. And the straightforward approach would be just to maximize the likelihood, log likelihood, because we assume the Markovian structure. So that likelihood can be decoupled in sum of individual log likelihoods for each triplet of observations. And we need to maximize this with respect to parameters. But the problem is that this likelihood is intractable. It's because in order to calculate it, we need to integrate out the latent variable z. But since the model is very complex, it is non-linear model, we cannot do it explicitly, and so instead of calculating this log likelihood explicitly, as is often done in the Bayesian inference, we are going to use the evidence layer bound approach. So the idea is as follows. Okay, this distribution, the posterior distribution of the latent variable z given our observations, it is intractable as well because of the same reason. And so what we do, we approximate it with the variational distribution of z given x, where the parameters of that variational distribution are given by nonlinear functions of the input itself. So this is a nonlinear function of the input x. And as such nonlinear function, we again use the neural network. So it is a neural network with other parameters, with some different parameters. And so what we get an approximate dynamics. So the approximate distribution of z given x is given by this Gaussian distribution. And when we predict the future value of the latent variable z hat, we just need to squeeze the variational distribution approximating the distribution of zt given xt. We need to squeeze it through the Kalman equation, and we get a Gaussian distribution with these parameters. That's it. And also we can predict the future value of the time series given the latent prediction of the latent code, prediction of the latent variable. It will be given by the Gaussian distribution with mean value calculated by a corresponding convolutional neural network when we take as inputs the predicted latent code. And so it can be proved that this is not the result of the paper, because this is a standard result from the Bayesian machine learning. So it can be proved that the likelihood can be lower bounded by the following function. So it is a linear combination of lower bounds for each log likelihood of each data triplet, and this lower bound is given by this equation. This equation can be explained as follows. So actually, this is the log likelihood of the observation x when we are given its latent code, and this latent code is generated from the variational distribution, which approximates the true posterior distribution of the latent code. And this is the log likelihood of the real observation, future observation, when we predict it from the predicted latent code. And this is just a regularizer. So our variational distribution approximating the posterior of the latent code given observation. So this variational distribution shouldn't be too complex, and probabilistically that means that the Kullback-Leibler divergence between the variational distribution and the Gaussian distribution should be small. In practice, we optimize this lower bound plus some additional regularization, but okay, it's not important now. So, interpretation. As control U, we use features of macro data. We squeeze these features through the neural network, parameters of which we also train. And as I said, this loss function here, it can be interpreted as a combination of the loss responsible for estimating that X sub t is accurately recovered from Z sub t. Also, it is the part of the loss function responsible for estimating how accurately Z sub t plus 1 is predicted by the corresponding value of Z sub t, and how well we predict x t plus 1 from the corresponding latent code on the previous step. So this is the interpretation of the lower bound which we obtained. And now let me show you the results. So this is how we forecasted revenue for a single vintage. So by red here we depict prediction, and by green here we depict true value. And these gray lines here, these are quantiles which I obtain from the corresponding posterior distribution. So thanks for the Bayesian approach, we are able to simulate predictive intervals. So we can not only predict point estimates, obtain point estimates of the prediction, but also we can obtain a predictive interval for that for the point prediction. This is the example of how the forecast looks for a single vintage for another single vintage. And this is how the forecast behaves on a group level. So group level means that we average predictions, we sum predictions over different vintages and compare it with a real revenue for a corresponding group. And so we observe that the prediction follows the true values quite accurately. So in the paper, in the corresponding paper, also we compared this approach with standard approach based on gradient decision trees, and with standard recurrent neural networks. We achieved better results because we use that idea of predicting in the latent space. As I mentioned earlier, there is a significant dependence between components of the time series, and because there is because of that significant dependence, we need to reduce dimension and make all predictions in the low dimensional latent space. And because of that, with our model, we were able to achieve better results. And when we use standard recurrent neural network, we don't explicitly take into account the lower dimensional structure of the data, and because of that, the accuracy is worse. So that's it. Any comments, questions?
So Evgeny, thank you for your talk. It's time for questions and comments. The offer invites you. Do we have any?
Yeah, I guess maybe the topic is a little bit mathematical, too mathematical.
I have a few questions.
Yeah.
So the first question was whether you assumed any structure in space and time on your variational approximation. I didn't see the details on the covariance. I guess you skipped it perhaps, or I missed something.
So let me show. This is the idea. So we assume that the value also, okay, the vector z, it is a low dimensional latent code. And we assume that the components of Z are independent.
Okay, independent in space or time?
They are independent in space.
Okay.
And in time, they are, of course, dependent.
Yeah.
It's because we use these dynamical models. So, of course, in time, they are dependent.
Yeah, I see. But do you think it would be a better assumption to assume some dependency in space as well? Because you mentioned that it is important that the more closer time series in the latent space become also kind of closer related to each other. Or, I mean,
well, in principle, of course, when we assume here not a diagonal covariance matrix, but a general covariance matrix, so our variational family is richer. And because it is rich as a function class, we can, that means that if we use a richer function class of densities to approximate the posterior, that means that we should be able to approximate the posterior beta. So in principle, this can improve the results on the one hand. On the other hand, we will get some, unnecessary computational problems for sure, because for sure, we will, in some cases, the corresponding covariance matrix will be degenerate when we will be estimating it.
mm-hmm.
And actually, in principle, because we project the data into the low dimensional space, it is very reasonable to assume that in that low dimensional space, the latent variables are not dependent. So we disintegrate all the dependency because of that projection. So because of this, still this assumption is reasonable. Although, as I said, we can better approximate the posterior if we use here the non-diagonal covariance matrix.
Okay.
So, but taking into account that the sample size isn't big, the data, macroeconomic data is often noisy, I don't think that this will lead to a significant improvement.
So yeah, so you can also look at this as a part of regularization in a way, this independency here. But another question, you mentioned that you compared to some baselines, but I mean, to me, the most obvious baseline is some linear space state model, and which would use exact inference on that. So have you compared to something like
so
Mars,
unfortunately,
which is much simpler, but which assumes like an exact inference on the latent space, but of course has a very much simpler model.
Yeah, so thank you for the question. Actually, unfortunately, I didn't include that table in the presentation. It is in the paper, but we compared that with Varmax model, vector autoregressive moving average
with external variables.
Model with external variables.
Yep. Okay.
It doesn't explicitly assume any latent structure, or so it is a classical model, but actually this is a standard approach, and so that model it gives worse results.
Okay, and just out of curiosity, where did you implement the approach? Was it implemented in some probabilistic?
No, we just use the PyTorch because here all these operations are very standard. I mean, from the Bayesian point of view, this thing is very standard for Bayesian machine learning. So the only non-standard thing here is that in Bayesian machine learning we don't often consider time series data. We usually consider just IID data, and here we have this Markov dynamics.
And do you have the code available somewhere?
Unfortunately, not now, because actually it was an industrial project with the bank, and it's not good to share that, unfortunately. But actually, it's not a difficult thing to implement this, because this, as I said, this is a standard thing for Bayesian machine learning.
Okay. Yeah. Thank you.
More questions, please, if any. I think that I have one question, which maybe may help to our audience to understand something related to neural networks. Am I right that you use fully connected network inside, or it was something more sophisticated?
No. Actually, here we have time series data. So time series data is just the data consisting of, real values, right? And so we just need some approximators to represent the dependence of, say, time series the values on latent values, right? And it's well known that for approximation purposes, fully connected networks with several layers are quite good. And taking into account that here we don't have a lot of data, it's better to use fully connected layer networks with not many layers, like 3 or 4, not more.
Okay, and do you think that there is somehow a trend to use complex neural network architectures from natural language processing? Do you think this is a good trend and this model?
Well, it depends. As usual, it depends on what application do you consider. Many networks from natural language processing are really powerful, like all those BERT, Albert, and other transformers. But for this type of data, you just don't have enough samples to train such complex models. And so I'm not sure that is a reasonable thing to apply here. So here we get some success only because we exploited significantly the low dimensional structure of data. That is, the time series components are significantly dependent, because these time series components correspond to different banks which have similar business, similar territorial proximity, and so they are really correlated. And this is the reason of this success. Otherwise, with such small realizations, it's not possible.
Okay, I also know that in industry they sometimes use ready-made models for time series prediction, like Prophet from Facebook. So can you maybe comment, is it somehow useful benchmark?
Well, possibly it could be a useful benchmark, although we didn't use that. In principle, in that library, I haven't seen really so very specific models besides more or less standard ones. So in terms of as a library, it is convenient. So it has all good methods for time series modeling, classical and the new ones, but
Okay. So thank you very much for.
So I mean that if let me explain the motivation. So if we initially, when we were solving this problem as just an applied project, we tried several standard approaches, like gradient boosting decision trees, because it's a very standard in applied data science, first to try either linear model or gradient boosting, and we were not successful with that. And so this is the only reason why we started to dig deeper and tried to construct some complex such complex model, only because of that reason. And so I guess that if we benchmark on these data sets methods from Prophet library, the story could be the same. Of course, we can combine some engineering in some standard stuff in engineering way. So we can combine, for example, autoencoders to reduce dimensionality as a first step. And then in that reduced dimensionality, we can use some standard classical model for time series data from Prophet library to model the dynamics. And then we decode predictions back in the original space. So possibly that approach, engineering approach, when we combine several standard things, it will also work in this for this problem. But when we use the Bayesian framework, we just do the same, but in a more elegant way. So all these steps are combined into one pipeline.
Yeah, and I remember you mentioned something like confidence intervals, similar to those in conformal predictions, right? So it's another advantage of the technique. You can see.
Exactly.
You can estimate uncertainty. Thank you very much for this nice and careful explanation of the things used, the models and their prospects. And now this track is finished. Now it's the time for a short break. Before the invited talk on graph theoretic methods in computer vision by Marcello Pelliot. So to join it, please use the link to track A in the mail that we gave you before. Thank you very much.
Thank you very much.
Bye-bye.
Thank you.
Bye. And what time, by the way, the track will be?
If you mean invited talk,
Yes.
it will start just in 7 minutes.
Okay, good.
This is track A. And as for track B, where the remaining part of data analysis and machine learning is going to be continued, it is just 5 minutes past 1.
Okay.
Okay, thank you. Dear participants, hello once again. So since the track we've invited talk, track A, is successfully ended, I mean, not the track itself, but the invited talk, we are back here. And without any further delays, let us start with the first speaker. In this part, the talk is on supervised anomaly detection for semi-structured sequence healthcare data. It is presented by either Victoria, Vikina, or by Alexei Zaitsev. Yes, please share your screen and start talking.
Он тоже у Евгения Андреевича.
Hello, do you hear me?
Yes, I can hear you. Hope the others can do it as well.
Okay, could I start?
Yes.
Понял.
Okay, so I'm Victoria, and our work with my colleague Alexei Zaitsev is unsupervised anomaly detection for semi-structured sequence healthcare data. So fraud is widespread and very costly to the healthcare insurance system. All patient visits are coded, and doctor could code 10-minute visits as 30-minute, and it costs more. So insurance companies do not want to cover fraudulent patient bills. So our goal is to detect fraud. And taking a look at how classical anomaly detection task is formulated, assume we have a sequence of xi at every moment of time t. So first, we will recover the value of it using the rest of a sequence. Then we calculate the difference between real value and the predicted one. And this difference we'll call an anomaly score. And so having threshold for an anomaly score, we could define what is anomaly indeed. But what if these variables xi are not continuous? So the problem formulated is how to adopt this method for classification and how to deal with class imbalance within the sequence. So it actually comes from the nature of our data. For example, flu is much more frequent illness than any other. So we would have imbalanced data set. So why don't we satisfy with solutions we have? First, in a healthcare field, there are only one source of available data. Papers are based only on handcrafted features, and current works only answering the question which doctor was subjected to fraud, but there is no answer like where exactly fraud was made and when. And secondly, only supervised methods are investigated. Audit is responsible for labeling data, and auditing data is limited and expensive, and labels are usually old or could be out of date. So in general, unsupervised anomaly detection on discrete sequences are not explored well enough. Now researchers are focusing on first token level models like LSTM, for example, or sequence level model like, for example, RNN-bus attention. And so summing up, our aims is first to develop unsupervised anomaly detection for discrete sequences. And secondly, to identify fraud in a healthcare insurance that would first, of course, to find detect fraud itself, and the system could potentially reduce expenses of insurance company for labeling the data. So speaking about what exactly we're going to do, develop the method that uses classification errors as anomaly scores. Second, we have to come up with an approach which handles multi-class class imbalance within discrete sequences. And we should aggregate scores to get one number which describes a sequence as a whole. So this is the general structure of an algorithm. First, here are the time series of one particular patient. He described as a sequence of prescribed treatments or visits. Then, using LSTM neural network with embeddings or sec-to-sec model with attention, we obtain predicted treatments. Then we should somehow define what is error. We would discuss it later. And then, having a set of errors, we would apply some aggregation strategies like max, sum, and so on. And we get an anomaly score. This is one number which describes a sequence. And then with expected recall, we could apply threshold and define what is anomaly indeed. So speaking about the models, we use two approaches. So in general, networks are used to obtain probability distribution on next treatment based on a previous sequence elements. So first approach is LSTM neural network. So we have embedded layers of our features and two LSTM layers and dense. And for sec-to-sec model, we used bidirectional LSTM as decoder, unidirectional LSTM as encoder, and we also use attention. So speaking about how we define errors, so from using these models, we obtain probability distribution for every sequence elements in every timestamp. So now, as we have the predicted element, we should define errors. So assume we have an ideal classifier. So the right label will give for the right label, the classifier will give probability 1. So we define error as 1 minus probability. So then for sequence of treatments for a particular patient, we have a sequence of these errors, and then we apply aggregation strategies. So that could be the end, but we have faced the class imbalance problem. We have more than 15 classes, and it leads to different probabilities distribution. So for example, for rare classes, probability 0.3 could be high, so we could be sure that this is the treatment which was prescribed indeed. But for more frequent classes like flu, for example, this probability could be 0.9. So we have to somehow normalize it. And we decided to replace error with the value of empirical distribution function of these errors. So as we had before, error as 1 minus probability. Now to deal with class imbalance, we have error as value of EDF of 1 minus probability. And we also decided taking a look not only on errors for treatments which were prescribed, but also for errors for treatments which were not prescribed. So ideal classifier will give 0 probability for the wrong treatment. So we would define error as probability itself and then the EDF value of it. So we either have vector of errors if we decided to look into only errors of prescribed treatments, or matrix of errors. And then we also applied aggregation strategy and get an anomaly score. So speaking about the experiments itself, Allianz Insurance Company kindly provided the data set for us. So we had about 380,000 patients. It's about 3 million visits. We had quite low fraud rate, so it's only 1.5%. We also had 2 kind of sequences, which means that so every patient visit is coded somehow. there were two approaches of how to code it. So we do not code it anything by ourselves. It was a data set from insurance company, as I've mentioned. So there were two ways: 2,000 classes of treatments and 17 classes of treatment time. So it's somehow aggregated. And here you can see the class imbalance picture. So we do actually have highly frequent classes and many of rare classes. So, and for you to understand how single input sequence looks like, so we have, again, sequence of treatments that could be coded either with 17 or 2,000 classes. Then we have patient features like sex, age, and so on. And we have label. So what is patient subjected to fraud or not? So label we actually use just for checking the quality. So speaking about the results, first LSTM-based approach. This is the overall quality for 2,000 classes and matrix of errors, and it actually gives better result in comparison with vector of errors. So we did obtain ROCOG 0.74 and PROG 0.04, and with expected recall 80%, we obtained precision 3%, and using EDF function, we increased precision on 0.5%. So speaking about sec-to-sec approach, first notice that if you see the numbers, like precision is 3.2%, and for 2,000 of classes is 3.5. So in general, token and sequence level models for this particular problem provide similar performance. And what is interesting finding also is that using 2,000 classes, which of course costs more to label, just slightly increased the quality of a model. And we also compared with like open source baseline, like we have open source unsupervised anomaly detection algorithm isolation forest. We used word-to-vec embedding of our tokens, and this model could not correspond to the expected recall at all. So here you can see the difference between our model and the baseline. And despite the fact that precision around 3% sounds low, it actually automated the process of anomaly detection by 2 times. Like we had 1.5% of fraud detection in raw data. Now using this algorithm, we detect 3 or 3.5% of fraud cases. And so discussions of results. We obtained same quality of LSTM and sec-to-sec approaches. They both superior at the baseline. And EDF approach improves quality of anomaly detection, but it gave improvement only for LSTM model. And speaking about limitations, firstly, there is no open healthcare data set that we can compare quality of on another data. Second, as far as our approach gave opportunity to detect particular place, like time where fraud was made, it would be interesting to compare, but there is no labeling data from this granularity. And of course, there is a gap between supervised and unsupervised approaches. So for exactly this data set was conducted experience with supervised models, and it gave PROG 0.24 in compare with our 0.07. So about the novelty and innovation, we developed an approach to handle class imbalance sequences in anomaly detection problem. And we made it in a level of error aggregation. It improves precision. So speaking about healthcare, this is first and only unsupervised research based on patient discrete sequence data. We compare it for different number of classes, and that gives us an opportunity to detect fraud on particular visits in general. And speaking about application, this model could be applicable to any fraud detection problem with tokenized sequences with large number of classes and small. We propose solution to handle a sequence imbalance. And for healthcare, this is state-of-the-art and supervised anomaly detection algorithm, which optimizes the process by 2 times. So yes, that is. Thank you for attention. You are welcome with your questions.
Thank you very much for your talk, Victoria. And it's time for questions. If you have any, please welcome. Okay, it seems that there are no questions yet, so I would like to ask a couple of quick questions, maybe.
Mm-hmm.
One of them is about your problem. Am I right that this is not a multi-label problem? It is a multi-class problem?
Yes, so in every step, like for example, if we're speaking about 17 classes, assume we have like 4, like assume a patient visited doctor 10 times. So in every time, like for example, we could see on the first 3 visits, and based on this, we have to predict the next one, the 4th, for example. And to predict it, we have 17 classes. So yes, this is for prediction, it's multi-class problem.
It's multi-class.
Or
there is a difference. There is a multi-label problem when your example may belong to several classes simultaneously, right? And there is, let's call it for simplicity, many class problem.
Oh, sorry. Yes. Sorry, there's not multi-labeling, so there could be only one label for particular visit.
Thank you very much. And the second question is, what about discrete-based methods like frequent sequence mining? They can also be used for classification. Usually frequent sequences can be extracted. You can count their frequency for each class and thus classify your case. Can it be applicable here or not?
You mean more or less complex models like neural networks, just to work with discrete sequences?
Yes. So this model are basically from pattern mining, data mining. If you have, I don't know, some events or items that your client bought, or maybe some actions that your patients did, some procedures there, how it's called, care pathway, sequences of events. So frequent subsequences can be extracted and used further to classify.
So of course it could be applicable. Just like we have chosen this method just because, like, actually this problem is quite the same as a bank transaction problem, like bank transaction, yeah, and so like only fraud detection, bank transaction, and we just decided to look into this methods because for bank transaction anomaly detection, this is state-of-the-art approaches to use LSTM as sec to sec, but of course less complex model could be applicable also.
So thank you very much. If you are interested, I may send you some links and references later.
Yeah, sure, that would be helpful. Thank you.
Thank you. Thank you. Thank you for your talk once again. And we are ready to proceed with the next talk, Advanced Data Recognition Technique for Real-Time Send Monitoring Systems. It is probably presented by Artem Apollonov.
Hello, can you hear me?
Yes, I can hear you. Hope the other listeners can do as well.
Okay, so let's start. Good afternoon. My name is Artem Apollonov. I am a student of Kazan Federal University. My presentation is about the development of advanced data recognition techniques that can be implemented to the real-time send monitoring system. Co-authors of this work are Yulia Maslenko and Artem Hasanov. After the brief introduction, I will present a series of laboratory experiments that formed the basis of this work. And then I will describe the proposed method, and finally I will present the result of training and testing the developed recognition system. When scent is being produced from an unconsolidated reservoir, it lowers the hydrocarbon production rate and increases maintenance costs. Solids in a produced fluid also represent a serious hazard to the wellhead equipment and its surroundings. Many popular systems are based on the measurement of acoustic emission and ultrasound power peaks detection. This approach has several limitations like high price and many false positives. Therefore, it was decided to develop a more adaptive system that can work in real time effectively. As the first step, we organized a series of experiments. We proposed special procedures to collect acoustic signals generated by the collision of sand particles with a metallic pipe wall. There were three main parts of experimental setup: the particle pipe collision system, the sand gas carrying flow system, and the high precision acoustic data acquisition system. The experimental setup is in the technology center of oilfield service company Sonogram LLC, Kazan, Russia. Right figure shows a schematic representation of test facility. Acoustic signals were registered at piezoelectric detectors. The detector signals were digitized with a sampling rate of 204.8 kilohertz and 24-bit digitization. Sand particles and water droplets were added to the gas flow stream using a dispenser system, as you can see on the video. The following experiments were performed: dry gas flow with added sand particles, gas flow with addition water droplets outside of the pipe with rain, sand particles outside of the pipe, and only dry gas flow. On the bottom of the slide, you can see samples of quartz propant that were used in experiments. Laboratory data clearly shows that high-frequency energy peaks are generated both by sand particles and by water droplets impacted on the outer pipe wall. Therefore, it is necessary to develop a more adaptive recognition system. Based on the laboratory data analysis, an algorithm based on machine learning techniques was proposed. The data input section prepares the signal data for machine learning model. It processes the acoustic signal data and extracts the significantly features for machine learning algorithms. It also can reduce to the dimension of original acoustic signal. This feature was used as inputs for ML recognition system. At first, the original signal was divided into separate segments and normalized. Further, in each segment, we extracted the features using various methods of spectral and quasi-spectral analysis. All of them show similar result. However, the fast Fourier transform is preferable for real-time monitoring system because of it requires less computational resources. We consider the following machine learning algorithm: support vector machine, logistic regression, random forest, and gradient boosting. The optimal training parameters for each model were varied in the following interval: a regularization coefficient for SV model from 1 to 6, regularization coefficient for logistic regression from 10 to 120, number of trees for random forest from 10 to 80, and gradient boosting, number of trees of gradient boosting from 5 to 30. On the slide, show results of training ML model. The result of quantitative error analysis of proposed machine learning models are presented in table. The most preferred relation between false positive 7% and false negative 9% was observed for support vector machine SVM in table. This model is much better in comparison with the algorithm based on the analysis of ultrasound energy peaks that show false positive 35% of the time. The random forest and gradient boosting models demonstrate approximate close result, but both methods are more computational demanding in comparison with the support vector machine model. Feature on this slide demonstrates the recognition system outputs the case of sand particles 2040 mesh, impacting the pipe wall in dry gas flow with the different delta pressures. High frequency peaks, more than 50 kilohertz, are clearly seen on the spectrogram, and the normalized power lock that was calculated for ultrasound range more than 20 kilohertz. This range is typical for popular wellhead sand monitoring system. The threshold value significantly depends on the gas flow velocity. The output of support vector machine model shows all the detected time intervals of the particle impingement. This figure demonstrates the same set of graphic plots when the water droplets impacted on the outer pipe wall as rain. The normalized power lock for same threshold and frequency range shows many false positives. But the output of support vector machine model demonstrates only one time interval with the false positives. In the conclusion, we can say that the series of special procedures were developed to collect acoustic data signal generated by the collision of the sand particles and water droplets with a metallic pipe wall. It allowed us to find the optimal features for recognition models. It was shown that the spectral analysis complemented with the ML models made it possible to distinguish sand signals from background noise and other noise sources like water droplets. The most preferred relation between false positives 7% and false negative 9% was observed for the support vector machine model. This model is much better in comparison with the algorithm based on the analysis of ultrasound energy peaks that shows false positive 35% of the time. Thanks for your attention. I'm ready to answer your question.
Thank you very much for your presentation on a real problem. And it's time for questions. Please welcome, if you have questions, ask the speaker. If we have no questions from the audience, let me ask a couple of quick questions. First of all, this is an applied problem, right? And you used some volume of data. Is this data set a private one, commercial one? So you cannot share it. Can you comment on it?
Yeah, this data set is used in organization is commercial, and we want to try to make it in our laboratory for our researchers, and we try to
distribute it.
To distribute it.
Okay, so it might not be an obstacle in case if you have a simulator of data of your type. For example, large companies like Schlumberger, they have their own simulators, and some of them are open, so you can download it and generate the data, then test your models. Certainly, they are maybe not that realistic, but at least they can be shared since those are simulated data. Okay, and what are the prospects of your approach? So the company is already using it, right?
Yes. Yeah.
And you are going to build a more advanced solution.
Yeah.
Using machine learning techniques.
Yeah, we also to try to extract feature with more new approaches. We want to try to use autoencoders maybe for extract features, and to use neural networks for recognition of our tasks.
Yeah, thank you. One of the previous speakers, Evgeny Burnaev, advised the researchers not to overly use complex neural networks, sometimes even fully connected. Rather simple architectures can help in the solution of your problem. As for feature extraction, I remember that TS-Fresh library in Python helped us a lot in one of the projects related to gas and oil industry to extract useful features that otherwise we could rarely extract manually. So thank you once again.
Thank you for your advice.
Thank you for the presentation, and we can go to the next presenter. If the presenters are here, we are slightly ahead of time, as I can see. So the next talk is Russia on the global artificial intelligence scene. And there are three co-authors, Dmitry Kochetkov, Alexander Biryukov, and Anna Yermolaeva. So if the presenters are ready, we can start. Otherwise, we can have a 5-minute technical break. Okay, I see the presenters among the participants. Let us wait a bit.
Dear colleagues, good afternoon. Can you hear me?
Yes, we can hear you, at least me.
First of all, just a few words. My name is Dmitry Kochetkov from the Graduate School of Business of the High School of Economics. I'm also the Deputy Editor-in-Chief of the journal Business Informatics. Let me express our deepest gratitude to the organizers of the conference for this wonderful opportunity to present the results of our study. We do understand that this is not pure computer science. This is science of science, in this case, science of computer science. And my co-authors are Alexander Biryukov from either Ruden University and Springer Nature, and Anna Yermolaeva is doing research in the area of research evaluation, especially conference evaluation, conference metrics. Anna will be the main presenter, but again, all the three authors are here. So after the presentation, you will be able to address your questions to any of us. So Anna, the floor is yours. You are welcome.
Thank you. I would like to present our research, which is called Russia on the Global Artificial Intelligence Scene. In this paper, we analyzed Russian position in the international research on AI published in conference proceedings. We look at the top AI conference defined by the Australian Core and Microsoft Academic Conference rankings and use the citation information from Scopus. The Russian government has been paying a lot of attention to the development of AI in recent years. For example, at the end of 2019, Russian government created the Department for Artificial Intelligence and Innovation. In October of the same year, the President of the Russian Federation approved the national strategy for the development of AI until 2030 and proposed the introduction of AI in public administration. Recently, Moscow started a 5-year project to improve conditions for the development and implementation of AI. In addition, in 2019, AI training programs were launched in 100 Russian universities. As more than 60% of scientific research conducted in computer science are published in the proceedings of conferences, it is important to carry out research. The same statement is true for AI research, where the most of the original results are published in conference proceedings. Also, the important question, how Russian researchers should choose conference with a high rate to publish. In the course of our research, we included the following steps. In the first step, we have identified a list of top conferences in the field of artificial intelligence. We used two data sources, the Australian Core 2018 conference ranking and Microsoft Academic Field Conference rating. We filtered core conferences by the artificial intelligence subject area and received 364 conferences and a star rank 19 conferences, the latter denoting the top conferences. We also took top 20 conferences on artificial intelligence from the Microsoft Academic Database, which lists 1,601 conferences on AI. As both lists overlap, as a result, we received a list of 31 conferences. In the second step, we computed the number of citations received by the papers published in the proceedings of those conferences. This was based on the Scopus data, time frame from 2010 to 2019. Data were taken by year as cited articles from the same conference for this time period. We used Scopus because it covered all the conferences in our analysis, except for IEEE InfoVis. Here we can see 8 conferences are indexed in all 3 databases, and we can consider them as a core. During the next step, we defined the metrics for the citation analysis. The citations per paper CPP metric can be interpreted as the expected citation rate. This concept is related to a number of widely used metrics as the impact factor. Finally, we calculated the citation rates of publications by Russian authors in the conferences proceedings listed above. A publication was considered from Russia if at least one author had Russian affiliation. This gave us the actual citation rates for the authors from Russia. The metrics used in the analysis allow us to tackle both quantity publication output and quality citation dimension. MNCS is a size-independent item-oriented citation indicator. It can be defined by this formula, where N is the number of publications, CI is the actual citation rate, and EI is expected citation rate. If this indicator is interpreted, then if MNCS greater than 1, the real value is greater than expected. If this indicator less than 1, the value is less than expected. In other words, it helps to identify publications which outperformed expectations. Normalized citation metrics are widely used in analytical tools. For example, field-weighted citation impact in Elsewhere, Scival, and category normalized citation impact in Claritative Analytics Insights. In both cases, citation rates are normalized by publication year and source type. In our case, we were dealing with the sources of the same type, so the normalization was based on publication year, title, and affiliation country. Proceedings of IEEE Information Visualization Conference haven't been indexed in Scopus. That is why we had to exclude it. This table presents the results of calculations for the remaining 30 conferences. The conferences marked with a star, it is conference with MNCS greater than 1. And bold acronyms highlight the core 8 conference. First, the extremely small number of publications by Russian scientists at this analyzed conference proceeding is really striking. In almost all cases, it is less than 1% of the total number of publications. There may be several explanations. The growth of the publication activity in Russia started with the launch of the 5 Top 100 Academic Excellence Project in 2013. Effectively, one can only see the results of this project since 2014. only the second half of the period we analyzed. And the publication culture in most of the disciplines, except for computer science, is based on journals. As for citation, in 13 cases out of 30, underlined with red lines, the mean citation per paper for Russian document is greater or equal to average for this conference. So actual citation rate of Russian authors is greater or equal to the expected citation rate. However, it is challenging to estimate citation rates based on such a small number of publications. Correlation analysis showed a relatively high rate of Pearson's correlation between the mean citation rate of conference proceedings in general and the citation rate of publication by Russian authors. The results of correlation analysis we can see on the figure. Thus, the expected citation rate is a theoretical probability, and the actual citation rate is experimental. Theoretical probability is probability that is determined on the basis of reasoning. Experimental probability is probability that is determined based on the results of an experiment repeated many times. With an increase in the number of observations, the actual citation rate should approach the expected rate. It is also interesting to observe that the average citation per paper for core conferences is twice that for the entire set of publications. We compared publications of Russian authors. Therefore, focusing on the 8 conferences seems to be rather promising strategy for increasing one's research impact. Another observation is that for several conferences with the more 10 publication from Russia, MNCS greater than 1. ACL, ECCV, ICCV, ICML, ICRA, Interspeech, and SMC. This might suggest that Russia AI school is particularly strong in those areas, even though this claim requires further investigation. While we aimed at creating an objective list of AI conferences, where the selection of conferences is guided by clear criteria, there are a couple of shortcomings. As the AI is a very popular topic now, our selection is by no means comprehensive and subject to biases. For instance, core only lists computer science conferences of relevance for the Australian community, thus excluding non-core computer science conferences. Adding conferences from Microsoft Academic partially addresses this bias. While conferences such as RCAI and AIST are very popular among Russian scientists, they were not included in the list, since in the study we focused on the top conferences defined by the Microsoft Academic and Core rankings. We are planning to address these shortcomings in future studies. In particular, it would be interesting to look at top conferences by authors with Russian affiliation and compare how those differ from the conference preferred by the international AI community. Also, we would like to explore the temporary dimension and observe how the publication strategy or Russian scientists change in response to the research excellence initiative. For instance, we could split the data set into publications before and after 2014 and check the impact of the 5 top 100 academic excellence project and how it affects the place of Russia in the international AI community. Thank you for your attention.
Anna, Dmitry, and Alexander, thank you for your talk. Now it's time for questions. So this is the talk somehow reflect the state of the art in publication process. within AI-related venues, highly rated in terms of presence of Russian scientists there. So I expect somehow intriguing questions here. You are welcome. Do we have any questions, please? It seems there are no questions yet, so let me ask quick questions as well. You mentioned that one of the possible, how to say, prospects of your research might be the study of influence of Russian excellence program for top universities. And for the current moment, what is the most valuable part of your research for the community? Maybe it's a clear call, we should publish more in top venues, or we should try to publish more at top venues. It's a call to Russian researchers, or maybe there are some other insights that you can stress out. What are the findings for the community?
Thank you for your question. If we go back to our results section, as I told, in bold, the conferences with where expected citation rate equal or more than theoretical. And if Russian researchers will be published more in these conferences, they will get higher citation rates.
And visibility, that's for sure.
I can add here, Dmitry, your question correlates with the motivation of research. Actually, our first motivation was the question of my friend from Russian government, who is partly responsible for the national strategy of artificial intelligence. So where we are now, this was a long answer to the simple question. At the same time, I think our main highlights now are the list of core conferences. So 8 conferences that are indexed in all the databases we analyzed. And the second finding is the list of conferences where our citation rate is higher than global average. So we can assume that we are good in these areas because artificial intelligence is not one discipline or one field. There are a lot of subfields within artificial intelligence. So probably we can focus on the areas we are really good at.
Thank you, Dmitry. I also appreciate that you mentioned a Russian conference on artificial intelligence, since it has quite a long history. I joined it maybe only in 2006, but it was already well-established conference, even without publications in well-indexed venues at that time, and it's now developing. So, asking whether Russia is on the global artificial intelligence scene is a nice question, but the value to the global artificial intelligence presence may be transferred by local communities as well. So, this community has a long history. As for AIST, we are somehow helping for the development of AI-related research. We are present almost 10 years on the stage, and we also have some publications in the past, like Data Science Map. This is a social network analysis related studies where publication graph is studied mainly in the connection between researchers, as far as I remember. There was also a publication by Andrei Kutuzov and Irina Nikishina, as far as I remember. They compared NLP track of AIST and the dialogue conference in terms of reviewing differences and so on and so forth. So I think it's a very interesting direction for reflections to obtain new knowledge for us, being AI researchers, and for maybe the government representatives, since they are responsible for new policies. So I like this direction of work, as the reviewers who carefully read your manuscript. So we would like to thank you once again for the presentation and for the study. We would like, we anticipate as it continues. Thank you very much.
Dmitry, I like this, Alexander. I just want to add one more thing, because hearing your discussion and Anna and Dmitry answers, I think it would be also interesting to look at certain point, also for that researchers see the results of, where international researchers in AI publish and where Russian researchers in AI publish. And right now we looked on top conferences, but it would be also interesting to see like Russia specific view, what are top venues for AI in Russia, which citations people receive there, and whether it makes sense to switch from some of the maybe more local venues to global venues, and where this research will receive more impact there or not. So I think it's almost like social engineering for the global AI publications research community in Russia.
Yeah, thank you very much. Just my comment on Data Science Map. It was a paper probably presented by Rostislav Yavorsky maybe 2 years ago. They really analyze Russian researchers, how they are connected in terms of co-authorship or maybe through different common fields. They analyzed their citation graph. Maybe they extracted the data from Google Scholar at that moment, so we need to check. But in case you are interested, you can try to collaborate with Rostislav and the team. Rostislav is one of the AIST co-founders. And I believe our NLP community, represented by Andrei Kutuzov, can also somehow collaborate and help in this direction. But they asked, as far as I remember, different questions about 2 conferences. You mentioned local conference. I would like also to mention not local conferences, but niches, that is smaller communities than, say, deep learning or the whole machine learning. There are some examples like formal concept analysis. This is lattice-oriented approach to data analysis, or rough set theory. Sometimes they are not highly rated in terms of A-star conferences, but by core Australian ranking. But anyway, they are well represented AI-related scientific schools, so it might be also interesting as well to identify such large niche topics and to see what are the Russian impact there. If you pose your question, what is the Russia on the global artificial intelligence scene? Thank you.
Thank you.
Thank you very much, Dmitry.
If we have no more questions during our discussion rather than question answering session, we can stop here and go to a break. Okay. So we do not have more questions. Thank you all the participants who took part in this section. I think that we'll continue already after lunch, and please note that if you would like to listen to Nikita Semyonov, the invited speaker, you need to connect to track A rather than track B. So then natural language processing will remain in track A and process mining will start in track B. So thank you and bye for now.
Bye.
Ну, не знаю, ну, московскую везли, а где Широко живет? Она живет, и что?
So, dear participants of our process mining track, it's my pleasure to open the session. And so it is the time to start. The first speaker is Anton Rigin, I guess. And so he will present the talk titled Data and Reference Semantic Based Simulator or DBNets with the use of Renew tools. So just it's my pleasure to invite the speaker, and you have about 20 minutes. Yes, but better not more. And please, so just share the screen with your slides.
Yeah, could you see?
Yes,
Yes, fine. So you can hear me, you can see me, and you can see my screen, right?
Yes.
Fine. So hello everyone, my name is Anton Rigin, and together with Sergei Shashakov, we have done work which I will tell you about now. It's work about such formalism as DBNets and our developed simulator based on this formalism. During my speech, I will tell you about why we have done this work, what we have done, and how we have done this, and what will be done in the nearest future. If you will have any questions, please ask me at the end of my speech. And if you are interested, you can see the source code by following this link. So why we have done this? Let's consider a trivial example. You have simple system, for example, task tracker, and for simplicity, let's consider it a safety critical system. What this system can be? For example, there are some employees, and there are some tickets, tasks that they should execute. Each ticket can be assigned to employee for execution. Yeah, some tickets may be not assigned in the moment, and some employee may have no tickets at the moment. Yeah, some idle employees, and we want to validate this system. Yeah, if it is real safety critical system, then simple testing is not enough. We need some formal methods. For example, to validate that each employee has not more than one ticket in the moment for execution. And what should we do for formal modeling here? For example, patronets are often used for modeling such concurrent systems. But if system interacts with the database intensively, then patronets cannot model it directly, since they aim at modeling a process, not a data state. So I have said about Patronet. Let's remind what the model is here. In the left upper corner, you can see the example of Patronet for example for mutual exclusion. What does this mean? There are two processes, and there are places. Places in, for example, in this net, it is just in which place, in which part this process holds. In common, it's just place for storage some resources. Resources are also called tokens. Yeah, and there are transitions for moving tokens. And in this PageNet, we can guarantee that two processes cannot go into critical sections, yes, C and G simultaneously. Also, there are some extensions of PageNet, colored PageNet. It supports data types, which in many sources are also called colors. Yeah, for example, there can be some tuple and so on. And also there is reference nets. Reference nets allow to use tokens which are references to objects. Firstly, it allows to model real programs, for example, Java programs, since as you know, all objects in the most of variables in Java, yeah, are reference to objects. And also this nets in this net tokens can be referenced to other nets. In this case, we can call this net as hierarchical net. But as it was said, the patchiness and these extensions don't allow to efficiently model data manipulations. And several years ago, there was invented such formalism as DBNets. They combine process model and working with data together. And this formalism consists of 3 layers. The upper layer, which is called control layer, it's just colored patcher net, but with some extensions, additional types of places, and so on. Data logic layer is intermediate layer between control layer and persistence layer, and persistence layer is just a relational database with its schema, with its constraints, consistency rules, and so on. And these 3 layers allow to model not only process, which is in control layer, but also the data state. So let's consider this example for the same simple task tracker. We can see these places. They can store some tokens, some resources, for example, tokens. These 2 places are view places. The left 2 places, I mean, they can retrieve the data from the database. Arrows and lines are arcs. These 2 arcs are read arcs. They allow to read data from the database. Rectangles are transitions. They allow to move tokens, and also in DBNets, actions assigned to them. So it means that when we fire transition, the action is performed on the database. And the red arc is just rollback arc in case if after assigning the 2 ticks for one employee, then consistency rules are violated, so we roll back this action. This is just another example for tax information system. Here you can see in the upper you can see the control layer of the DBNet, and in the bottom you can see the database schema in persistence layer. So, so we have found one implementation in public of DBNet. It was plugin for CPN tools, but it we want also to support reference semantics in order to give ability to model real programs, for example, Java programs. And we have found a tool called Renew. It's a tool for reference net simulation. It's very well plugin extendable, and it allows to manipulate Java objects as tokens right in the net model. So we have decided to use this as a base for our simulator. So just to develop our simulator as a plugin for the Renew tool. So just want to explain you what we have done. So Renew supports reference net simulation. So it means that it supports reference semantics. DBNet support data semantics. And we combine it all in our simulator, which is plugin for Renew. And also I want to say that persistence layer is implemented using SQLite. It's just for information. So this is class diagram for our plugin. It is not very readable, but the main idea is that this development required to extend and reuse functionality to the Renew without modifying existing code of Renew. Because if we would modify something, it was not plugin and it was not so easily for install and so on. So we have extended the number of plugins of Renew, for example, plugins for working with formalism like nets and the elements, for simulation nets, and some utility plugins like UI plugins and so on. And also we extended Java C based compiler in order to compile DBnets, we have used the original renew reference net compilers and extended. We have developed our own DBnet compiler based on this. And also we have used some additional libraries. So, but as I said, the main idea we extend the existing functionality. So what does it mean? For example, renew has some functionality for net elements, places, transition, and so on. And we have reused it as much as possible. But if something where it was necessary to change something, to override something, we have overridden this implementation. Yeah, and so for example, view place extend and override place, I mean traditional net place, and DBNet transitional extend and override traditional net transition, and so on. And we have got the simulator. I will show it you now in live demonstration, but for this, yeah, let's just see in this example. It is this it's this example of a simple task tracker, yeah, and it is modeled in simulator without rollback arc. I will now explain you why. And yes, rollback arc also rollback also implemented this simulator, but so it's not very easy to achieve rollback for demonstration in live demonstration during the speech. So I will show you a separate example for demonstrating the rollback work. Yeah, so now we will see this example, this simple task tracker example without rollback arc. And now we will see how data in database changes after transition pairing in step-by-step mode. So let's run a renew with our plugin. Yeah, this is a renew pilot which allows to build nets from these elements, yeah, these places, transitions, and so on. And we have added special elements for DBnets, DBnet transition, we place special arcs, and so on. So let's open this example about task tracker, yeah. And yeah, so before I will explain you what this example consists of, I want to say that renew compile nets using compilers, yeah, and we have developed our own DBnet compiler. So let's switch to this. And now, so this is this alliance database schema definition, in contrast with original DBNet definition, where it was just a list of tables and the columns and consistency rules. We have decided to use SQL just to allow user be more flexible while working with this program. And for example, here you can see this, yeah, for example, on each employee can work with only one ticket because of this unique constraint. So also there's some queries and actions they parsed as in an original example. Yeah, params, facts to add and facts to delete from the table. During the execution action, facts are deleted, then new facts are added, but it all executed in one transaction. So here's a control layer of DBNet. This is places. This is transitions. They are the actions assigned to them that are performed during these transitions. These are arcs, and these two places are view places for retrieving data from the database. Queries are assigned to them to retrieve this data, and they connect with transition by read arcs. Now let's see simulation step-by-step mode. Yeah, so we have do some number of steps, yeah, and I just want to say to show you that, for example, if we can give renew to right to select the transitions for us, as I have done now, or for example, we can select it manually. For example, this one. And let's see, for example, the database state. Yeah. Let's see, for example, table for which some employees are responsible. Yes, for some tickets. And yeah, this is really 3 tickets now. So now, for example, we will release one of employees from one of tickets. Yeah, it will be executed and deterministically. And yeah, there -1 responsible employee. I mean, so or after this we can assign. Yeah, and yeah, maybe I have clicked 2 times because all tokens was transmitted, and so on. Also, we can, as I have said, we can give renew right to choose transitions for us, or we can even start an endless simulation and see this. So now let's terminate this simulation and go faster. And sorry, the next example is for task tracker with rollback arc. In order to show you how rollback works, we have specially broken one of actions. I will show you. So let's see. Yeah, one of actions, and its assign was broken. Now all tickets are assigned to Anton. What does it mean? That this rule of that no more ticket for one employee at a time will be valid fastly. So let's see it in step-by-step mode here. And yeah, so for example, now if we will try to assign, then this token is returned to this place, not transmitted to this, because this employee already has tickets, 1 ticket, and so consistency rules are violated during this action performing. And the last one is example for taxi. It just might possibly will be more understandable since this is more trivial. So let's see this. Yeah. So let's see how this work. Now we have 3 free drivers of taxi. Yeah, we have no any data of booking because it's no booking now. Yeah, but 3 drivers. So now we create booking. Oh, I'm sorry. It's just reserving. It is just reserving of driver. Booking is in fact booking is created in database scheme. Yeah. So we are reserved, and now we see that it is not free driver. And after finalize booking, the data is added to the database. It's just hard-coded data. It's hard-coded, not in code, I mean, but here. Yeah, in these transitions. And now let's finish. So if you're talking about applications of these tools, yeah, it allows to model DBNets using Renew graphical interface and simulate them with usage of Renew. And it's applicable for simulating those systems where it's necessary to consider not only process but also data manipulations, and also the systems which are with reference semantics, for example, systems written in Java. Yeah. And this tool is first implementation of DBNet with reference semantic support. And it serves as a, so we plan to use this in our nearest experiments with some more than some possibly real software system with DBNet. And also we plan, possible ways to continue development of this plugin, to introduce support in hierarchical nets as one of the most popular application of reference net, providing for user ability to input real data as in real systems during the simulation and increasing some usability parameters. So here are references which we have used during slide preparation. And now that's all. If you have any questions, I am glad to answer you.
Yes, thank you, Anton, for a nice talk. So questions, please. We have several questions. So then my question is more so technical or organizational. So did you contact with Renew developers? So just did you show them your solution?
No, not yet. Not yet. We have not yet talked with the Renew developers, and I will think about this. But the there was several years from the last Renew update, despite the fact that it's really good system for modeling reference nets. I just haven't seen any others because CPN tools is not for reference net, for example. Yeah, but there was no any updates of Renew for several years. I will think about this, but I'm not sure that they continue this project now.
They do so. Just as it was contacting Daniel Molt, and so just to
okay. Then I think
it's really interesting. Yeah. So just questions, comments. Then thank you once more. So just it's really an interesting work. So just I think there are some ways to continue it, and hope so. Maybe you'll do it or somebody else. Thank you.
Okay, thank you.
Yes, and now, so Dmitry, will you announce the next speaker, or shall I do it?
Certainly. Hello, everyone. Let me announce the next talk. The next talk is entitled Checking Conformance Between Colored Pattern Nets and Event Logs. The talk is co-authored by Julio Cesar Carrascal, Halil Nesharawi, and Irina Lamazova. So Julio, I believe that you are the main presenters. You are the main presenter. You are welcome.
Thank you, Professor Ignatov. You see my screen for the audience?
Yes, I can see.
And you hear me well as well?
Yeah, that's
perfect. Thank you. So, well, good afternoon, everyone. My name is Julio, as introduced by Professor Ignatov. This work has been done in cooperation with Halil Mesharawi from the University of Constantine II in Algeria, and also my supervisor, Professor Irina Lomazova, also from the Higher School of Economics in Moscow, Russia. I am a doctoral student and researcher in HSC. So this work, as introduced, is about how we can check conformance. This is an area of process mining using a more rich model, colored Petri nets. It's well known, but perhaps not addressed sufficiently in this problem of conformance in process mining. And as well using event logs, which is real data. How we are going to organize our presentation. In the beginning, I am going to introduce the area, which is the research problem and our goal. We are going to introduce briefly about these two items, colored nets and event logs. Then I'm going to describe the method in which we use both the nets and the event logs. And we are going to conclude the talk talking about implementation that we have done in Python, some experiments, and we conclude with the contribution that we are doing to the domain of process mining and how this could relate with other works, even in the broader field of data science. So what's conformance checking? Here the idea is that we would like to detect where a system deviates with respect to its specification. So we have some information system, we have some rules, and also we have observed behavior of the system, which is what I call here the event log. So the event log are traces. So this records what the system it has done, what's executed. And in the other side, also we have the system specification. So it's the set of rules, so how the system should behave according to some design. But so the idea here is to model the specification of the system using a formal model that I will introduce, which is called the PetriNet, also introduced by Anton before. And to compare here the PetriNet model against the event log. So maybe just a few words on PetriNets again. So here we have three different important elements: transitions, which model the activities of the system; the places, which model the buffers or the conditions; and the tokens, which model the resources. So here the idea again is that in the conformance checking problem, this represents the modeled, the expected behavior of a system. And it's important here to check that for such basic case of PetriNets, we focus just on the control flow. So we are modeling what the system can execute, which activities, and in which order. So this is what we call the control flow. For example, the system executes B just after B was executed. Other important thing is that these models are executable. So there is a transition rule called the firing rule, in which when the firing of a transition consume tokens from input places and produce tokens in output places. And in this way, we can model how the system shall process the resources. So here the idea then is that we are going to compare each of the traces in an event log again on top of a PetriNet model. For example, Sigma 1 says the system executed A, B, D, and E. According to the model, this is okay because it complies with the ordering established: A, B, then D, and E. But this Sigma 2 does not comply because it's saying that B the system executed twice B. And according to the model, this shouldn't be allowed. So this is a deviation. So this is what is conformance checking in short words in process mining. Which is the problem? So it's quite noticeable that the majority of these conformance checking methods that are available in the literature, and also we will speak shortly at the end of this presentation, they just focus on that control flow. So the question is how we can determine the correctness of the system based also on data resources. So I put an example. Let's consider that there is some system in the system, we need to execute a track activity. And this can be executed just by looking by orders and sell orders, by looking these data elements. So what has been the goal of our research? To develop a conformance method to validate data-driven behavior of the system. So then again, I put here again the same scheme of conformance checking, but some things change. So now instead of a simple PetriNet, I have a colored PetriNet model. So I will introduce this model soon. And also we have the event log, but the event log also will change. So it's not anymore just simple traces listing activities, but also these events in the traces, they will have some resources attached. So having this, our method will be able to say if the data resources, the objects, are being correctly processed by a system. So of course, we evaluate the system by looking at the event log, and we see whether or not it complies, comparing it against the specification modeled by the CPM. So in CPMs, colored PetriNets, so the idea is that tokens now, they model objects of different classes, and this is why it's called colors. And also the ARC expressions, they will be labeled, will be labeled with expressions that it will allow us to describe how these resources shall be transformed. So before introducing the example of a CPM, so I will jump to the study case of trading systems. So we are going to see a model based on how a trading system shall be executed. So in trading systems, we have buy orders and sell orders. So this represents the two classes of objects that the system manipulates, which are received by agents. These orders, these objects, they are inserted in lists that they are called order books, and they are closed to trade. So we begin. The first point is that, as I said, in colored nets, the tokens, they represent objects. So here in the blue token could represent a by order, and here in the right side, these tokens represent sell order. So they are tuples with some attributes. So there is an identifier. This is saying some arrival time. 22 means the price, and 3 means the stock quantity of the order. How stocks of some company it's going to buy. And the same principle in the right side. So these are other constructions of a net. So I am going to show it incrementally. So you see now that also we have expressions that when a transition fires, it's indicating how we are going to consume the resource. So this tuple here, this is an expression, it's saying that from place P1, we are going to take this whole element and we are going to produce it back as indicated by this output arc in place P3. And the same principle in the other side for the sell orders. And they will arrive to some buy side and sell side of an order book. So we are modeling here an order book, how it's processed. Then eventually, there is an interaction point, other transitions which model the trade between both objects. And they arrive to some places. Also see here that whenever they trade, this quantity here Q, it changes to 0. So we are modeling that the order quantity fell to 0 whenever they trade. Of course, there are more complex, there is more complex behavior. There are other kind of trades in which, for example, they just trade partially some quantity. So we allow these operations between components of tuples. And also, for example, if they do not trade, also they can be canceled. So see that the quantity here goes to 0. So in overall, this is a model, a colored Petri net model representing the behavior of a trading session in an order book. So this is an example of a colored Petri net model, modeling the specification of such systems. So how should be the event log that we will use? So now the event log, of course, will be traces, and each of the traces will be a finite sequence of events as you see in the table. But now each event will have not just the activity that the system executed, but also will have a set of resources. So for example, here in submit by order is saying that in event 1, the system executed submit by order with this resource. Or for example, E7, the system executed trade 2 using this set of resources. So for each activity we have, for each event we have an activity and a set of observed resources. Other important point is that we can extract from all these sets of resources, which are the distinct resources in the trace. And we can know it by looking the identifiers of the resources. So here identifiers are the first values of the tuples. So we can distinguish here three resources in this trace: B1, S1, and S2. How our method works. So let us consider the replay of this trace on top of the model. So the first thing that we are going to do for this trace is to extract which are the distinct resources in the trace and to populate some initial places that they represent the starting points of each class of objects. So here we distinguish two classes of objects, or I have said two classes of resources. So we have B1, a by order, and two orders, sell orders, S1 and S2. So in the algorithm, in our method, these resources are transferred to the initial places, and we begin the replay of the whole trace. So how we do it? So for each event, we are going to fire the transition indicated by the activity. So the activity says submit by order with this resource. By looking the identifier, B1, is there B1 in the input place of the transition labeled with this activity? Yes, so we fire. And the same principle for the next events. For example, new by order. We need to fire new by order using this resource B1. It's B1 in this input place. Yes, so we fire. So it might look easy, but in the way we could find it may happen that we could find some troubles. And those are the deviations that we could find. So I will list them. So which are the problems, the strange things that we can find on the way while replaying all these events in a trace? The first point. So one deviation that we could find is there is an error due to absence of input resources. So it's visible, no? So we have an event and we have some resources. And we need to select when firing T, which are the distinct resources in the input places as seen by the event. So it may happen that there can be no resource in an input place as indicated by the event. So we evaluate this formula. So for each input place, we are going to see that there should be exactly one resource as indicated by the set of resources such that exists its corresponding value as a token in that place, and they correspond. So we look at the identifiers by looking the identifiers of the event. So if this is false, if this expression is evaluated to false, this means that the real system executed an activity with actually one resource that was not permitted or available. Other kind of errors that we can find. So we are also going to consider that rules assigned over transitions, partially defined. So that means that not all transitions will be defined with a rule. But if we are firing a transition that is assigned this priority rule, we are going to evaluate this expression in which we are going to evaluate the true value of each of these formula. This is the local rule, a local rule in each input place. So R means the token that has been selected to consume. MP is the token, so it's the mark in the state of this place. So which are the actual values that's here? Another question, so each of these local rules will ask, is the selected token R the resource that should, by some priority, serve it as next from P? So for example, for what this can be useful? So let us suppose that there is a priority rule assigned over transitions that model the trades. So we would like to check. So let us suppose that by binding according to the observed event, we have selected R1 and R2 to consume from both sides, the buy side and the sell side. So each of these formulas, phi buy and phi sell, are going to check. Is R1 the best order on its side? And it's R2 the best order on its side? Of course, I do not elaborate more in detail this formula, I just define it here. But internally, what they do is to check whether R1 should be actually the next one to consume, and the same one with R2. So in this case, we can check whether the real system is consuming resources according to some defined rule. And the final point is to check difference between real and modeled processed resources. So how does this work? The idea here is that after execute, so let us suppose that we executed the activity. So the question is, did the system transform the attributes of each resource as specified in the model? So in the model, we have some produced resources, and we would like to see if these resources that were produced, their overall state, by looking the values of their components, are exactly as the values observed in the event. Because in the event, the value of the resources are their values after A was executed. So if there is some incongruence here, it means that the real system updated some attribute. So here was some attribute that actually in the model was not changed as such. And this inconsistency could suggest that there is some corruption of a value of a resource. So here I summarize the algorithm. So as input, we have the colored net, some set of initial places for each class of object, and we have the event log. I will jump to this line. So for each trace in the log, we do what I said before. So we populate initial places with the distinct resources of the trace. And for each event of a trace, we do the following. We select the transition to fire. We check if there are resources to fire. If they are, we select a binding. After binding, we check if we selected a correct binding according to some priority rule, which is defined here internally in this method. Then on line 9, if everything was okay before, we fire. And after firing, we see if what the model produced, these resources that were produced, are exactly as indicated by the resources observed in the event. At the end of this, so we will do as many events in a trace and as many traces in a log. After finishing these two loops, we put as return one set of non-fitting traces. So we are going to record which are the traces that were not okay. And also one simple metric, which is going to be a ratio of how many traces were completely replayed. So I will jump to the implementation and the experimental evaluation of this method. So we developed an approach, an implementation of this algorithm using snakes in Python programming language. This is a library well known that facilitates the prototyping of different high-level classes of Petri nets, not only colored nets, but also it works with other classes. And this implementation is available in our repository in GitHub. And the visitor of this repository will find the folders organized more or less like this. So conceptually, our project is organized as this. So we have, this is our method, the conformance checker using this technique. And we're going to take from one log from a repository of logs and one model from a repository of models. The logs, so in the paper, we wrote the experience working with two types of logs, artificial and reals. Here in this talk, I will just briefly comment about our experience with real logs, but also in the paper, we elaborated about our experiment with artificial logs, which actually, these artificial logs, we generated them using the same models or models constructed in this repository that we have. The output of our technique is the set of non-fitting traces, as I showed in the algorithm, but also we output a specific information about the deviations that occurred in each of the traces. I will go with an example. I will exemplify the use of our method with this real scenario. So this is an experiment with a real event log. So we consider it from a recorded set of network messages from a trading system. So the idea here is that we have a set of network messages that they record the activity between the system, some trading system, and some agents. And we extracted data from this using a preprocessor in Java. It's also in our repository, this preprocessor. And we extracted trading sessions. So an event log where each trace represents a trading session in an order book. So we have different traces here. Each of these traces, so in total, we got 73. And these are the total number of events. So in average, it's like 30 events per trace. These of the traces, they represent the activities in a specific order book. For example, one trace is for the people who is trading Yandex. The other trace for the people who is trading Apple, and so on and so forth. So we have individual traces. And the idea here is to replay each of these traces on top of a CPM model, which specifies how these order books shall work. So these are some initial results after executing the method with a real event log and the CPM model, which, by the way, is exactly the same model that I presented at the beginning. So we are modeling simple sessions. So this is the conformance results. So of the 73 traces, 8 of them, they had one deviation. And this fitness value indicates such ratio. So it means that 89%, more or less, of the traces were okay. But 11%, I mean, these guys were not okay. So which problems they had? Well, in one trace, there was a rule violation of the trading. And in 7 of them, the model produced one resource that it was not transformed as such in one of the events of such traces. It's very interesting that in one file that we call artifacts deviations, we can see specifically what happened in each trace and which was the problem. So this is a screenshot of the file with information about the deviation occurred in each of the traces that were bad. Here I put the number in this picture. In this column, it's the number of the trace. B is the timestamp where the event that was bad occurred, which is the activity that was wrong and the kind of deviation. So in this case, we had resource corruptions and rule violations. And here in the code, we were able to extract which was specifically the problem. So for example, here in RC, so in line number 2, for the trace 58, it says, for the activity trade 2 occurred at this moment, it happened that the resource with this identifier had this state observed by this tuple. But actually, when it was operated in the model, replayed in the model, such a resource had this state. So you see here that the price was different with respect to the price of this when executing this activity. So here there is some problem. It's very interesting also that all the activities that had some problem are the traded ones. So what this can indicate us? So of course, here we see that there are rule violations and corruptions originated in trade activities. This is useful for experts to confirm if there is really a failure in the system occurring in those activities, or instead, if the model should be slightly refined. So perhaps there is something in the model that should change, and we did not model accurately the specification. For concluding the work, so what we have presented. So we have now a conformance method using colored nets to validate data-driven behavior of the system. In particular, we focus whether the system is correctly processing objects, resources of different classes. We show it an implementation based on Python. In the paper, we wrote evaluation of artificial and real event logs. Here in this presentation, we just addressed real logs. Future work that we are studying now for perhaps less express invariance of CPNs, for example, not having tuples, but just resource identifiers, to try to keep replaying traces once a deviation is found. Because it could happen that, okay, if we fix one deviation, perhaps there won't be more deviations in the trace, but it can happen that there are other deviating events. So also we need to keep replaying the whole trace to detect them. And the second point is that also in our research, we focus not only on data aspects, but also aspects related to agents. So we model and validate also agent behavior. And we are studying other method of conformance checking based on agents, as I referenced here. And it would be, we are studying how we can integrate the method that I presented here with this other approach. Finally, the final slide. How this work relates to process mining and the broader field of data science. So in process mining, actually the strong part, the strong body of the literature on conformance checking do not address completely this work of conformance checking using data. There are notable exceptions. So there are works by Felix Manhart and Massimiliano De Leon in which they use rich models of Petri nets, for example, Petri nets with data. But the problem of this model is that the backbone, so what I call the backbone, the main control flow, it neglects the model of data. So it's a model in which there are just black tokens in the control flow in the model, and the data are just satellites attached to transition locally. So it does not fully model the data transformation as incipients. So it's quite limited. So we believe that for this work, there is an important contribution in this field. The second point, how this can relate to in data science? Well, in passive analysis, which is our subject of data science, the idea here is to validate the system by looking, not the online system, by looking data post-mortem. It's clear that this is very similar to our technique. And in association rule learning and sequence mining, here the idea is to try to identify patterns and to see if the data complies given rules. But the problem of sequence mining and association rule learning is that they don't handle concurrency. They don't modeling these patterns of petriness like choice, parallelism, and so on and so forth. And you see here that in this model that we have presented, we can exhaustively define rules in one single model that later we can compare such model systematically against each of the traces of a log. So, well, I finished the presentation. Thanks for your attention. If there are comments, questions, feedback, I will be glad to answer you.
Julio, thank you very much for your energetic talk. So it's already 5 o'clock, and those who are here since the early morning, they might be tired. But we have maybe time for a short or quick question. So if any have such a question, please ask Julio.
Yeah, I have. Can I?
Yes, yes, please.
Yeah. Okay, can you hear me? So, Julio, thank you so much for interesting talk. So just my general question would be, so what is the place of your technique among other techniques which are used for doing conformance checking in process mining? So namely, we have aligned-based conformance checking, and it seems your version are much more like token-based conformance checking, yeah?
Yes.
So, did you compare your approach, your technique with existing techniques? And so let me just ask the following question, because it's tightly related with the first one. So as I could understand, so while replaying traces, so if you find first deviation, so the first event which could not be replayed, so you simply, as I have understood it, so just simply drop out the trace. And so if you have for that example with only 73 traces and almost 2000 events, so is it good when you find an unreplayable symbol and unreplayable characters, so, and then you will throw away the whole trace?
Okay, so I go with the first question.
Yep, thank you.
Well, you asked me whether, so of course this technique is replay.
Yep.
So of course there are more complex. So talking, if we are going to classify conformance checking techniques between replay and alignment, of course alignment it's more advanced than replay, but we are considering here what we can validate. So here we focus that, okay, not just the control flow, but just, I would like also to validate behavior driven by data. In this sense, this work with Manhattan De Leoni, they work with alignment using Petri nets with data. So if I compare again my work again those ones, so which is the difference? They use alignments, so perhaps it's more advanced than using replay. But their minus, that would be my plus, is that they use a poor model, which is Petri nets with data. So they cannot model this transformation of resources like I did. So it's more on in the modeling part, perhaps. So as for the second part, yes, so we are just replaying till it's possible. So because there is an approach of Van der Waals in which they replay. So whenever you cannot replay an element, so you artificially will inject input token, a token in an input place. But what's the problem there in our approach? And it's, thank you for your question, because I didn't say it, that we consider a CPM model with several restrictions to make tractable the conformance checking problem. And we cannot inject resources as Van der Waals does, because we assume that our resources in the model are distinct with distinct identifiers. So we could have the risk that we are injecting a resource that is already available in the model. So you see, we would have clones, duplicates, and this shouldn't be allowed. So we are studying now with the professor and also with Halil Meshrawi techniques or heuristics. So for example, instead of injecting resources, to jump them. So to move a resource that should be executed, that is in other place of the model, and to transfer it to the input place of the requested transition to fire. So we are working on that. This, pragmatically speaking, this approach to replay just till it's possible, I mean, talking about improving the system could be nice, because perhaps by fixing one deviation, for example, we could avoid the domino effect in which several pieces fall. So we perhaps by fixing one event, other events won't be anymore with deviations. Of course, there can be, so it can happen that even by fixing one deviation, other deviations still appear. So it's still needed to check the whole trace. So we are working, we are researching on that part. So perhaps it looks very complicated with work with alignments for these very rich models, colored nets, and even in the work that I mentioned, also we are working with validation of agent behavior using these kind of models that you know, nested Petri nets. So perhaps at this stage of the research, it could be very difficult to work with alignments.
So thank you for your answer. So just a very brief comment, very brief note to the very brief reply to the Julio's answer. So I guess it would be quite interesting to provide an ability to switch between modes of the process of conformance checking, because sometimes injecting even the phantom resource could be much more interesting than just dropping out the whole trace, because as you know, so now we deal deal with logs that are queried, that are obtained by using this Wireshark or something like this tool. So, and sometimes we can lost some events not because they were not occurred in system, but just because of these technical limitations of our net or something like this one. And so in these very cases, I guess it would be quite interesting to be able to restate these skipped or lost events just as a way to for the further for future work. So it could be quite interesting to add such a mode in your conformance checking. So thank you again for your talk and for your answers. Thank you.
Thank you, Sergey, for your. I will take it into account.
Thank you, Julio. I hope now your reviewers, your peers are satisfied with
okay.
the practical results that they mentioned to present. I also saw the experimental evaluation on real data, if I'm right. And now we are switching from process mining track. Thank you one more time to all its
Thank you, everyone.
To social network analysis track, which is one of the three main historically introduced tracks, even from the first AIST. So let me introduce shortly my colleague, Alessia Kaltsova from St. Petersburg Department of St. Petersburg Division of Higher School of Economics, the laboratory of
Social and Cognitive Mathematics.
I am the updated name, and it's the stage for you and the track. Please, Alessia, you're welcome.
Yeah, thank you, Dmitry. Yeah, I'm happy to chair this session. I would like to invite the first presenter, Victoria Semishkina, to start sharing her screen of her presentation co-authored with Olga Gerasimova, linking friends in social networks using hashtag attributes. I'd like also to remind that we are 8 minutes behind the schedule and that we have 25 minutes per full paper, including questions, and 15 minutes for short papers. And I'm kindly asking to presenters to limit their talks to 20 minutes at worst, but better to try to talk no more than 15, 16 minutes. So we have plenty of time for questions and discussion. And I hope we will be able to catch up with the schedule. Please, Victoria, the floor is yours.
Hello, my name is Vika. Today, I'd like to tell you about research on linking friends in social networks using hashtag attributes. This work was done under the guidance of my scientific advisor, Olga Gerasimova. Please ask question at the end of the presentation. Okay, let's start. I'm sorry. Okay. All we feel that social networks became an integral part of our life. They allow us to communicate online and exchange exchange all kinds of information. In our research, we consider the social network called Instagram and hashtags as a key tool for finding relevant information and new friends. We choose Instagram as one of the most popular hashtag sharing platforms. To browse content by different tags, users can follow information interesting them, check current trends, or find their needs. You can see the typical Instagram post, which has the following items: username, location, photo or video, likes, post, hashtags, comments. Analyzing the conditions that cause people to subscribe to each other on social networks is a well-known task for developing recommendation systems. It's clear that people like to communicate with those who have similar interests. Hashtags can be considered as one of the forms of interest description. So we use hashtags for a link prediction task on friendship graphs based on data scraping from the Instagram. We decide to collect Instagram data related to 3 Far Eastern cities: Blagoveshchensk, Khabarovsk, Vladivostok, and compare similarity based on several machine learning methods for link prediction task on these data sets. In our work, we use following technology stack for developing the data retrieval bot: Ubuntu server for database deployment, Java, Java Spring Boot framework, and MySQL. We collected data from the Instagram based on the geotags of chosen locations. We could not use the Instagram API because the location ID attribute was removed 2 years ago. As a result, to automatically collect Instagram posts, a data retrieval bot was written by Java. We used object relation mapping to create the Instagram database. We used tools mentioned on the slide for work with Graph. This slide shows visualization of the graph for the location of Blagoveshchensk. We could not visualize other two graphs using Gethy because they are too big for this software. This slide shows summary statistic of data sets. We built 3 friendship graphs based on geotags for the following locations: Blagoveshchensk, Khabarovsk, and Vladivostok. We collected posts with the given locations. Next, we identified users who created these posts and built friendship graphs. We mean that 2 users are friends if they follow each other. We removed users with posts not containing any hashtags. Hashtags were preprocessed in the following way. We converted to lowercase and removed all symbols, except letters and numerals. We analyzed most popular hashtags in our 3 cities. We defined topics of popular hashtags. Hashtags were translated from Russian expect the Instagram class and were ordered by popularity from top to bottom within categories. Because of the idea from data collection, many popular hashtags contain names of the cities. The current quarantine situation related with COVID-19 also produced many relevant tags. Also, general hashtags about season, celebrations, or popular services and retrieved. We have not several interesting patterns. While Vladivostok is a seaport, hashtag sea is most popular in the city. Different season preferences are identified. In addition, Vladivostok is also a tourism center. This is why there are more Instagram post advertising, hashtag photographer services than hashtag manicure, unlike other cities. We plot the distribution of the number of hashtags in each post for the united dataset of posts for 3 locations. Look at the left picture. There are around 50% of posts included up to 10 hashtags. The upper limit from the number or hashtag per Instagram post is 30. So we can see an increase of around 30 because there are many sponsored ad posts with a maximum number of tags. However, there are a few posts with exceeding limit of the number of hashtags. figure on the right illustrated distributions of the number of users according to the number of shared hashtags of 3 graphs. It can be seen that most people use quite a small set of hashtags. In the next figure, we plot the distribution of the number of times hashtag was shared in a post. In other words, we analyze the frequency of using hashtags. There are a lot of specific hashtags which are popular among narrow circle of users. Also, there are general hashtags, but their number is much smaller. It's clear and logical that both distributions look like the power law. Move to the main task and experiments. So we consider a social network as a graph G, which includes a set of nodes corresponding to people and a set of edges denoting the connection between them. And what is a link prediction? It's a task of predicting the extent of a link between two nodes in a network. We state in the link prediction as binary classification task. We predict one of 4 edges which appear in the next state of the network and 0 for non-existent edges. The back-of-words method was used to vectorize information about user hashtags. It's reasonable to choose only hashtags that were shared more than once, in other words, by more than one user. We obtained that there are a lot of hashtags used by only one user in our datasets. To receive examples for the negative class, we applied the negative sampling strategy. We randomly choose non-existent edges such that the number of the world be approximately the same as the number of existent edges for a balanced sample. Moreover, we aggregated results of live negative sampling. We split our data into training and test sets at 70% and 30% respectively. In the basic model for link prediction, we use cosine similarity and Jaccard metrics. These metrics were calculated for the test set containing existent edges and non-connected pairs of nodes from negative sampling set. The threshold for prediction was obtained on training step. We used a grid search from 0 to 1 with a small step. We predicted existence of edge if metric value was greater than corresponding threshold chosen for each metric. In our problem statement, each user is characterized by a set of hashtags and connection with other users. So we use 2 types of features: binary vectors describing use hashtags and binary vectors corresponding to a set of friends. We made 3 experiments to calculate the similarity metrics with different feature spaces. We can see the prediction accuracy using only hashtag is greater than using graph information, which support our hypothesis that users of Instagram and LinkedIn by their interest. However, the approach did not show sufficiently high accuracy. That is why we also looked at more advanced techniques using machine learning methods. We used the Node2Vec framework to learn low-dimensional vector representations for nodes in a graph by optimizing a neighborhood. To receive edge feature, we applied specific component weights function to note features for source U and target V, nodes of a given edge. We consider 4 basic functions for such edge embeddings. We considered machine learning models for binary classification tasks such as logistic regression and gradient boosting for features with Node2Vec embeddings only. Gradient boosting showed better quality in terms of all metric of average, weight L1 and weighted L2, edge functions and logistic regression. However, the situation is opposite the Hadamard edge function. if we add features with vectorized hashtags, we obtain better results for logistic regression with all ages function except average. Generally, combined features lead to higher quality, which supports one claim and core idea of the paper. Conclusion. From a technical point of view, for our study, we wrote a universal Instagram data retrieval bot, collect data sets, and build friendship graphs. We made experiments on link prediction using similarity-based and machine learning methods to predict edges in the graph. We took into account hashtags and structural information about the graph. As a result, we obtained the hashtags can be considered as a good attribute for linking friends. For the future work, we aim to study other methods of graph or hashtags embeddings or machine learning methods. We also can look at additional features related to social profiles of Instagram user for our problem of friend recommendations. Thank you for attention.
Thank you, Victoria, for perfect timing. And now the floor is open for questions and comments.
I'm sorry. I like answer the question in Russia because my English so.
I'm not sure if we have any. Yeah, we have a non-Russian participant here, so I'm sorry if you intend to participate in an English language conference, then be prepared to answer in the language of the conference.
It's okay, she can answer in Russian.
Oh, okay. Any questions, colleagues? Yeah, while colleagues are thinking, I have a couple of clarification questions. So in the second round of your modeling, you used logistic regression and some other algorithm, but I didn't get what was used before that, the one that you weren't satisfied with.
Извините, я затрудняюсь ответить, немного не поняла на английском.
У вас во второй части использована логистическая регрессия, еще там что-то второе. И вы использовали это, когда вас первый этап не устроил, моделирование.
Да.
А вот что было, какой алгоритм был использован на первом этапе моделирования, который вас не устроил? Непонятно было из слайда.
У нас на первом этапе использовалась, то есть изначально мы использовали методы векторизации, как раз-таки back-of-words methods. Вот. А потом, получается, мы делали эксперименты и использовали логистическую регрессию и градиентный спуск.
Ну, смотрите, векторизация – это метод работы с данными, который вы подаете в свой алгоритм.
Да, ну, то есть это поэтапно я рассказываю, вот, и именно вот первый метод у нас был как раз-таки back-of-words метод, а потом мы использовали...
Это не метод моделирования, значит. Это значит, что вы на первом этапе решили представить определенным образом свои данные, на втором этапе подали их в логистическую регрессию.
Да. Просто, возможно, я как-то не так сказала, типа...
Извините, коллеги, давайте я соавтор Виктории, я могу помочь ответить на вопрос. Первый метод был использован на основе метрик схожести вершин, то есть мы считали две метрики схожести: косинусное расстояние и индекс Джакарта схожести двух вершин. Это значение было как признак для ребра. Вот. А потом мы подбирали порог для этой метрики с помощью grid search, и определяли порог, относительно которого определяли, появляется ребро или нет. Ну, то есть если значение метрики больше порога, то мы говорили, что ребро появляется. Если меньше, то говорили, что нет. Это был первый метод.
Понятно. И еще один вопрос такой серьезный. Мне кажется, что использовать методы логистической регрессии, что там, gradient boost, тра-ля-ля. Когда мы работаем на графах, может оказаться не совсем корректно, потому что у нас там не независимые данные. Особенно логистическая регрессия, она предполагает независимость тех данных, которые подаются. То есть у нас, например, можно использовать для классификации текстов, которые никак друг от друга не зависят, были написаны разными людьми в разное время, никак друг с другом не связаны. Однако сетевые данные – это данные, графовые данные – это данные, которые не удовлетворяют принципу независимости. Вот вы как-то это рассматривали проблему?
Ну, нет, конкретно эту проблему не рассматривали, а использовали логическую регрессию, поскольку она широко используется именно для задачи link prediction, как для задач бинарной классификации. Вот, и поэтому с точки зрения эту проблему мы не учитывали.
Понятно. Dear colleagues, has anybody got any other questions? If not, I'd like to thank the presenters for this presentation, and let's pass to the second presentation by Evgenia Yegorova, who is here, and her co-author Anatoly Surikov. Evgenia, you can start sharing the screen, and the presentation is entitled Emotional Analysis of Russian Text Using Emojis in Social Networks. Floor is yours.
Good evening, my name is Evgenia Yegorova. Today I want to introduce our research. The research was conducted together with Anatoly Surikov. The name of research is Emotional Analysis of Russian Text Using Emojis in Social Network. Sentiment analysis is a key task in natural language processing and has a wide range of real-world applications. Traditional methods classify plain text as positive and negative. We propose a method that is significantly different from traditional approach. In addition to plain text, we have analyzed ways to express emotions in a message and a variety of emotional indicators, emoticons and emojis. Digital footprints analysis using machine learning methods in social network is a compelling and knowledge-based task. To analyze text digital footprints, the required size of labeled data set is collected and machine learning methods are applied. For this research, we used a large data set of 6,000 short text messages was marked manually, which took a lot of time. The research aims to build a model to detect emotions in Russian language text. On this slide, we can see most relevant research. We have used in our research an emotional scale by Robert Plutchik. Robert Plutchik is a psychologist, created an emotional scale with 8 basic emotions: joy, trust, fear, surprise, sad, anticipation, anger, and distaste. Here we can see that joy is opposite to sadness, fear is opposite to anger, distaste is orthogonal to trust, and anticipation opposite the surprise. Plutchik emotional scale is the most referenced in scientific research, for example, in NRC lexicon data. The resentiment corpus was used for our research. The resentiment is a data set of posts from social network Contacte, and this post had already been marked in 5 classes: positive, neutral, negative, speech, and skip. For our study, we used posts with class marks positive and negative. The resentiment corpus was marked up at 8 emotional classes: joy, sad, surprise, distaste, anger, trust, attention, and fear. Experts have manually marked up 6,000 posts. Data collection on minority classes is ongoing. The article have presented intermediate result. The dataset was annotated by 4 experts manually. The annotation was performed following specific rules for experts. Any emotions from Plutchik scale that could be highlighted by experts in a short text was marked with positive markers. Not highlighted emotions were marked with negative markers. Most often in 77 of cases, the expert distinguished from one of 3 prevailing emotions in a post. The binary markup was averaged and used to generate the final data set. In most cases 91%, an expert can easily identify dominant emotions using the Plutchik emotional scale in a short text from social network. Data preprocessing. Data preprocessing consists of several types. The first, remove posts without emotional indicators, convert posts to lower cases, remove posts containing less than 10 words, remove contents including the mentions and the mails, remove punctuation marks, remove words that are not in Russian, and change emotional indicators to their text meaning. And then lemmatizing posts using Yandex.MyStem. The ratio of emotional classes to all posts in the dataset was analyzed after data preprocessing stage. We can see on the slide. Emotions have a strong relation with the sentiment classes. For example, the positive class above the diagonal consists of such emotions of joy and trust. The negative classes below the diagonal comprise sad, disdain, and anger. The neutral class in the diagonal consists fear, tension, and surprise. It can also be noted that there are much more positive emotions than neutral and negative ones. The distribution of emotional indicators in posts according to emotional classes allocated for this post are demonstrated on the slide. The presence of an emotional indicators in a particular class means that is more than 50% of posts that have this indicator, this class of emotional is highlighted. It's clearly seen that people are more willing to use emotional indicators expressing joy and sad, and such an emotional indicators class and attention has not received a single emotional indicator. In our previous research, the result we can see on the slide, this name, the alternative methods of sentiment analysis using emojis and emoticons, was applied to analyze not only plain text, but also to study how important emotional indicators in sentiment analysis. The study was focused on a set of posts from social network Contact. The models were built to predict 2 independent classes, negative and positive, with emotional indicators. Target model pipeline. To predict emotional classes, a model was developed. First step, we lemmatized text with highlighted emotional indicators, were vectorized using the classic TF-EDF approach. Emotional indicators are included in the dictionary, and then embedding constructions this way act as predictors at input of fully connected neural network trained to classify them into 8 independent classes corresponding to emotional on Plutchik's case. The target model pipeline we can see on slide is a result, a vector of 8 values is obtained, which demonstrates the probability of giving text message to belong to emotional classes. The test set included 1,268 posts, and training set was 5,000 posts. As the baseline was model based on NRC lexicon. The NRC emotion lexicon is a list of English words and their association with 8 basic emotions on the Plutchik emotional scale and 2 sentiment, negative and positive. The NRC lexicon was translated in Russian by machine translation. The vocabulary consists more than 11,000 lemmas from NRC lexicon. The model was built on this vocabulary. As emotional classes in the text was used, the averaging on the vectors of emotion classes included in the lemmas. Results. Validation results we can see on slide. As expected, due to strong imbalance of emotion classes, accuracy is considered to be an efficient metric to evaluate this model. More reasonable metrics is the area under the RAC curve and the area under the precision recall curve, which indicates that the model shows a satisfactory quality of prediction in three emotional classes: joy, sad, and fear. The article provides an insight into emotional analysis. The model developed in this research can be used to compile a variety of model ensemble for social network analysis. The model presented could also be applied to consider emotional dominance of a user behavior in social network and make prediction about their character. Conducted, the research will continue to improve the model performance for 5 remaining emotional classes. This requires additional research in a collaboration with psychologists. Thank you for your attention.
Thank you for your presentation and for perfect timing. And the floor is open for questions and comments. Well, okay, I have a question of clarification. When the texts were annotated, did it happen so that each text contained only one emotion and no mixture of emotion ever occurred?
Yes, we have some mix of emotion in annotation. And for example, we can mark up to emotion one in text.
So you choose only one emotion to mark up?
No. We choose, for example, you can choose 4, 3 emotions. It's not only one.
And then how do these texts enter into your data set? So you have, if you have marked up 3 emotions, you enter this text 3 times with different labels, right?
We had 8 independent models, but
okay. Yeah, also there is a small note that your list of emotions on different slides is different and there is discrepancy between them, and it also doesn't correspond to the list of Pluchik. There is no such emotions as distaste and attention there, and it's not very difficult to find which are the correct titles.
Yes, in the different
please go on.
Sorry. In the different articles, they used different names, and this corresponded to
Evgeny, please switch on off your mute your microphone.
Oh, it's okay. It's no. In different researches and articles, they used different names, and sometimes it's complicated to consider one.
Yeah, well, but attention is not an emotion, right? So it's anticipation.
Yes, but in some translations, sometimes it's something.
Okay. Okay, thank you. Anyway, are there any other questions? If no, I would like to thank Evgenia again. Our next presenter, as far as I understand, is Elena Zamyatina, who is presenting her work on the study of strategies for disseminating information in social networks using simulation tools with her co-authors Alexander Usanin and Ilya Zimin.
I'm ready.
You can start sharing your screen then.
And do you see my presentation?
Yes.
Good day. Let me present our report, study of strategies for disseminating information in social networks using simulation tools. At first, permit me to introduce authors of this paper. They are Alexander Usanin, student, Perm State University, Ilya Zimin, student, Perm State University, and I, Elena Zamyatina, associate professor, National Research University High School of Economics, Perm branch. And my second affiliation, Perm State University, because I have graduated from Perm State University and my co-authors too. I want to present the content of our report. Let me consider the content of our report. At first, I want to consider the motivation of our investigations. After that, let me discuss the objects and the methods of investigations. We offer to use simulation in order to study the strategies of dissemination of information in detail, more deeply. So we want to present components of our simulation tools, TRIDE-NS agent, which gather data from a real social network. And then we want to present the results of simulation experiments in TRIDE-NS. At first, it is well known that social networks become an integral part of human life. There are about 70 million active users of social networks in Russia, and accordingly to the Russian agency, Facebook was used by 152 billion people. Social networks are used not only by simple users, but also by specialists in various fields of science, marketing and education. So while analyzing social networks, economists receive information about transactions, about the influence of others on human behavior. Marketers use social networks to promote their products. Unfortunately, social networks are used by scammers and terrorists, and it is very actually to prevent the spread of these false, harmful, and life-threatening information. Let us discuss the methods of study these strategies. One may use the methods of social networks analysis, which is based on structural characteristics of social networks. The following metrics may be obtained. There are degree, diameter, centrality, mutual orientation, transitivity of connections, and so on. However, structural characteristics do not adequately reflect some aspects of the behavior of users. They can't identify causal relationships, so simulation methods can be used in order to investigate the strategies of dissemination or preventing information in social networks. And we may name the first methods static, and the second methods are dynamic methods. Most often, virtual social networks are explored. Virtual social networks may be represented by graph. Random graphs are used to describe virtual social networks, but there are some publications studying data from real social networks. So we decided to study not only virtual social networks, but data from real social networks too. And this slide, it is virtual social networks and the random graphs, Bolabosha, Riordan, Buckley, Oskos, Erdosh-Renyi, and the model of copy. Let us present simulation tools. Here you can see the requirements for simulator. And there are software tools for constructing internet graphs, software and linguistic tools for researching internet graphs, software and linguistic tools for simulation of the behavior of the users. In this case, agent-based modeling is a suitable paradigm, and software and linguistic tools to work with large volumes of data, to work with large graphs, introducing social networks. So you can see that we want to study social networks with the help of static methods and dynamic methods. And we want to study virtual social networks and real social networks. And it may be done with one software tool, TriDNS. It is our simulation system. It is distributed. And here is a model, simulation model in our simulation system. It consists of three layers. The structure layer. Structure layer represents a model structure. And after that, a routing layer. Model objects behave on the certain algorithms. And message layer. Message layer is used for description of structured message and rules of transformations. Here is the layer of structure. You can see here that structure layer of the model is built gradually by the structure layer operations. You can do you can delete node and add node, unit graphs, subtract graphs, and using structure constants. Here is a routine designing. A routine describes a behavior of one node in the model structure. The routine is a sequence of events planning each other. And it is the information procedures. Information procedures observes the object's behavior. It can connect to object routine and can trigger when the specified routing a variable has been changed. Here is the components of our TriadNet system. And now I'll want to say something about the agent for data collection in real social networks. We had some requirements for data collection. It is necessary to collect data on the topology of the social network. The relationship of users and their characteristics should be stored in the ontology. It is necessary to collect data and user actions. All events must have a time marker so that it can be used during modeling. All collected data should be saved in a format that will be understood both by the modeling environment and by means of the visualization and data analysis. The data should be relevant and at any given time. Some requirements for the agent. The agent must build an ontology around some limited part of the social network. The agent must monitor the actions performed by users and store information in the event log. The number of agent requests to the social networks should be minimized, and so on. Here is the structure of ontology. Ontology has the following set of the classes. Person, a class representing a user of social network. It contains the user identifier in a particular network. Community, a class representing the community that the user is subscribed to. It contains the community identifier in the specific social networks. And here is the relations in our ontology. Relations used in ontology has first name, has second name, has gender, and so on. Here is the structure of event log. Event log we received from program software, from software Pro-M. And here is the information about the user. The ontology read by simulation tools and used by simulation tools. And here is the information about user in simulation tool. Here is the example. At first, we have the ontology, and this example present the viability of our software. We added one friend, and you can see here that it appeared in ontology. And here is the example of a log of events. You can see here post seen, online, offline, post add, post copied, post liked, and it is the ontology in a simulation tool TriedNS. The results of a simulation experiment can be presented in two windows. It is the window with the users of with the users, and the second window is the results of the information procedures after the simulation experiments. And this window present one small experiment. Let us choose one post published by the community and see how long it would take to spread it in the web. Then we changed simulation model, excluding the node with the highest degree of centrality. Second simulation experiment showed that the number of steps for which the post reached user is in most cases increased. So we can see that our simulation tool works good. Conclusion. This work demonstrates the viability of simulation tool TriedNS for solving problems related to the research of social networks, including the tasks of disseminating various information. Using the proposed tools, the researchers can study both virtual social networks and real ones, use static methods, structural characteristics of online social network, and dynamic simulation. The specific log stores information about user behavior. To create the log, process mining methods were used to build a simulation model in the TriedNS environment. Software tools were also developed which help extract information from ontologies and logs. Researchers can build the model automatically. That's all. Thank you for your attention, and I want to hear your questions.
Thank you. And the floor is open for questions and comments. Okay, while the colleagues are thinking, I can ask a couple of clarification questions. I had some difficulties following you. So in your graph that you constructed, what were the nodes and what were the edges?
The nodes are the users of social networks, and the edges, the relationships between them.
Which type of relationships? There are many.
You can see here.
Not quite, actually.
No, it's quite. It is the structure of ontologies. It is.
So I'm sorry. A relationship is, for example,
and relations here.
A relationship between two users can be friendship or message exchange or some good exchange offline or retweeting.
It is so.
All of them together.
Yes.
All types of relationships in Vkontakte are edges in one graph. Okay, so is this graph weighted or non-weighted?
Graph is not weighted.
So if a user has any type of relationship,
it is ontology. It is ontology.
So it's not a graph at all.
Ontology is graph.
Okay. So what type? What was the task of simulation? I didn't get it. So what process or what features did you try
We
to
study strategies. We study strategies for dissemination of information. If we have users, maybe marketers, they want to disseminate this information more faster. And the second strategy is the preventing of harmful information. We had another work last year. We presented it in this conference too.
Okay. Okay, thank you.
And the goal of this work is to work with real networks, not virtual, but real web networks.
Okay, so you predicted or you modeled the speed of information sharing, right?
Once more.
Did you model the speed of information flow in this network?
Once more, your question. I don't understood.
Okay, never mind. I don't want to take too much time for my questions. Has anybody got any questions? Well, dear colleagues, if there are no other questions, let's thank again the presenter and pass to the next presentation. It will be presented by Ksenia Tikhamirova. It's her work together with Ilya Makarov, and it's entitled Community Detection Based on the Node's Role in a Network, the Telegram Platform Case.
Yeah, hello. One moment. Okay, can you see my presentation? It's okay?
I can.
Yeah, good. So my name is Ksenia, and I'd like to present you our paper with Ilya Makarov about community detection based on the node's role in a network in the case of Telegram platform. Their presentation will be separated into 3 blocks. In the theoretical background, I will talk about premises and the limitations of the study. Further, I will explain the methodology in details, and finally, I will talk about our results, how we evaluated them, and what plans we have for this research. The purpose of this work is to compare for community detection network structure features and strategy-based ones. Network structure features are features that we get according to connections between network members, and strategy-based features are features that we get from the behavior of nodes in a network. In this research, we use We use data of forwards. One moment. We use data of forwards of 100 politician channels in Telegram. Their dataset includes forwards from January to October 2019. Here in this research, we are talking about the communication network, and this network has a horizontal structure, but we can describe it using using 3 levels. The first one is authors level. Here, authors, they create messages and evidences in the network. The second level is distributors. They spread information in a network. And the last level is readers. Unfortunately, in the case of Telegram, we have no data about readers, but they are the last step of information proposition and essential additional information for community detection. And knowing nothing about the Telegram channel's audience, it becomes more difficult to detect communities. So our idea here is to use KPIs or performance indicators to recreate hidden connections between Telegram channels. We consider that the behavior of a node can be described with its performance indicator, and estimated performance leads to an understanding of what a node is suitable for. This way, the approach covers conscious and unconscious strategies of network members. And knowing a strategy or a behavior of a node, we can describe upper level, and it is the network structure itself. Now I will talk about methodology, and in this research we have 100 channels, and all of them can be authors or forwarders. That's why here we use bipartite graph. This way we can estimate nodes behavior better. And talking about behavior, we estimate this behavior for each unique message in our data set. So every node in the network receives a vector of estimations where one of these estimation is one of KPI, and we have 7 KPIs or indicators and their combinations. These indicators are separated into 2 groups, for author and for forwarder, and they are supposed to describe the strategy or behavior of a node in a network. In the case of author, we suppose that the goal of an author is to create quality messages which have a huge reach. And the first indicator here is my strength. It's the number of reposts of a message. The second one is their weakness. It's how many other messages the forwarders of this message have reposted. And in the case of forwarders or distributors, we suppose that their goal is to spread unique and quality information. And the first indicator here is uniqueness. It's how many other nodes in a network repost the same message. The factility shows the total number of forwarded messages by this node. Humility shows how many times one node forward another one. So in other words, we can call it biased one channel. And diversity shows how many authors at all the node have reposted in our data set. And moreover, we have a combination of these indicators. In the case of authors KPI, we can balance the strength of message with the weakness of its forwarders. We combine forwarders KPIs as well. And finally, we have total KPI, which combines authors KPI and distributors KPI. And if this value is below 0, they suppose that the node behave more as a distributor in a network, and opposite, it looks more like an author. So we got our vectors of estimations, and between these vectors, we count cosine distances, and we suppose that it is essential to have, for clustering, to have different distances between our vectors. So that's why we use the following indicators in the analysis: my strength, their weakness, uniqueness, authors KPI, distributors KPI, and total KPI. These cosine distances we convert into adjacency matrices, and using these matrices we apply Louvain and spectral clusterizations algorithms, and the results of these clusterizations we compare with the clusterizations based on a simple graph with the weighted edges. So, and with our clusterings, we estimate them. First of all, we are using modularity score, and here we can see that most of our clusterizations have a weak structure. Only Louvain clustering shows stable clustering, but if you look inside this clusterization, we see that this algorithm puts every single node in a separate cluster, so it's difficult to interpret. As well, weak structure shows Silhouette score. Kalinsky-Harabat score shows good value only for Louvain clusterizations, but we know that it's difficult to interpret. And Davis-Baldwin score shows good value for distributors KPI clustering. And here I need to say that this weak structure of clustering we see for clusterizations based on a simple graph. So it's similar in quality of clusterization with our proposed method of strategy-based features. And comparing these two approaches, we use rand index, homogeneity score, adjusted mutual info score, and they show that our proposed method is random or not similar comparing to clusterization based on a simple graph with weighted edges. Only Faulkner-Mello score shows the middle level similarity for spectral clustering. So as a result, we have a proposed method of strategy or behavior-based features for clustering, but it shows weak structure of clustering. The reason of this can be in chosen indicators or their combinations in chosen distance metric cosine one or in clusterization algorithm. To check real reason of these results, we can step back and check or test our method on random data that is similar to Telegram. In this case, we can control external conditions and test our method only on our 7 conditions. Oh, sorry. Only on conditions of our 7 indicators, and this way we can estimate how network members behave in these situations and how they communicate with each other. So anyway, further investigations allow us to deepen understandings of communication processes on Telegram platform. Thank you for your attention.
Thank you, Ksenia. And the floor is open for questions and comments. Okay, can then I ask a question or a number of questions? So far as I understand, your main result is that you get groups of either authors or distributors that are similar in some respect as determined by your KPIs, a combination of your KPIs. Is that right?
As I understand your question, it was an idea of this research to have similar authors or distributors based on their behavior.
Okay, then I wonder why at all you would need an approach of social network analysis of graph mining, because it looks like you are more interested in finding similarities between certain objects than in finding how they are connected. So there are different approaches to cluster analysis in which you don't need any distances, but you rather like work with their raw scores, and you find like how similar your objects are. So why would you use this graph approach?
Oh, yeah. It also was interesting to understand how they are connecting among each other, because it was in the case of politician channels on Telegram. So, and some of these channels are anonymous channels. So it was interesting how they are connected to each other to understand maybe some of these channels have the same author, for example, or owner. That's why I think it's closer to network analysis, that similarity. So it wasn't the point of interest to understand how their content similar, for example. First of all, it was about their connections, but it was difficult to understand their connection between. It's difficult to understand their connection because we know nothing about their audience, and we suppose that their similarity can be hidden in this audience because they want to influence the same people.
I actually fail to understand where connections come into your data. So you have some KPIs like the number of nodes that has been forwarded or something, and then you join it with some other similar KPIs, and based on that you calculate distance between all these users, and there is it seems there is no information about who owns the same channel or any other connections. Like, so.
Okay, yeah, I understand this. I think here we can. So the idea was to have clusters of these channels, and after that, having clusters, I think it should be the next step to understand owner relationship, for example. But the first here was clusters.
And also, so far as I understand, in the end, you collapsed all your indices or KPIs into a single index, and then you calculated the distances based on that. And it's no wonder that the graph is not well clustered, because you have only one value that is distributed somehow from 0 to 1, or from -1 to 1. I don't remember. And so it shouldn't be, it is difficult to expect that the graph could be very clustered in that case.
Yeah, in this case, if we would use only one, the last total KPI to estimate to make clusterization, yeah, it could be worse. But here we use all of our indicators. And we compare how they can behave in the clusterization algorithm. So it wasn't only one indicator.
Well, it is an interesting work. It was not easy for me to grasp everything. I thought that it could really be easier to make cluster analysis using all rows, or all 6 or 8 row scores, and to get a sort of multi-feature clustering. Then probably it could make your picture richer, but well, okay.
Maybe, yeah. Thank you.
Has anybody else any questions or comments on this work?
I have maybe one question. So since you deal with bipartite graphs, right?
Yeah.
You can also apply such techniques like formal concept analysis if you know what it is. That is maximal big clicks in graph terms. Do you consider this possibility? Also by clustering can be applied here.
Okay, thank you for your question. But I don't understand the technique that you described here. Sorry. Here we use the bipartite graph to count our KPIs. So maybe unfortunately we didn't use exactly bipartite graph for clusterization to compare with the proposed method.
Okay, if you would like, I can send you some relevant links if you would like to continue.
It could be great. Thank you.
Thank you.
So I'm sorry. So in the end, you are not using a bipartite graph. So you have nodes. All your nodes are users, right?
No, I can say we had a bipartite graph, but based on this graph, we count KPIs. So if look to the description of these KPIs, they are kind of connected with the structure of a network because some of them, for example, connected with the number of neighbors of a node, and this number of neighbors were connected based on a bipartite graph.
So you collapse bipartite graph into the just ordinary unipartite graph.
Maybe, yeah.
Oh, okay. Again, if in your bipartite graph you have rows, users in rows and features in columns, this also is a suggestion for this structure suggests thinking whether you really need a social network analysis approach as opposed to bi-clustering, as Dmitry has suggested. Because if you have two types of nodes, like people and places they visit, then you could think that this structure suggests bipartite graph, because places are not exactly features of consumers, of the people, the people who come there. But if you have exactly people and their features, then okay, it's not obvious that graph social network analysis is needed. Okay, anyway, thank you very much for your very interesting presentation. Any other questions, colleagues? We are ahead of our timetable, and I can't understand if we have the next presenters at the moment, Ilya Samonenko or Tamara Voznesenskaya or Rostislav Yavorsky. Is any one of those colleagues here? Well, if not, we have to make a break because this presentation is scheduled for 7 p.m. and it's 6:45 right now, and we can't require people to be earlier than their schedule, we all can go and have some tea or coffee. And I hope that someone will return at 7 o'clock and we will see if the presenters show up.
Thank you, Alessia. Let's hope for the best. I will
Okay.
try to contact the presenters in meanwhile.
Okay, thank you very much.
Thank you. Dear colleagues, let me check meanwhile. Are the presenters here for the talk? For the next talk.
Which one?
I believe how minimal degree of the social graph affects efficiency.
Yes, we are here.
Okay. Okay, so let's wait until 7 p.m. or when the session chair will
I'm
join.
here.
Okay.
So have we got the presenter?
I am Tamara Вознесенская.
Okay, thank you. So you can start sharing your screen and hopefully we'll hear the presentation co-authored also by Ilya Samonenko and Rostislav Yavorsky, how minimal degree of the social graph affects efficiency of an organization.
Yes, Ilya Samonenko is here. Rostislav Yavorsky, unfortunately, ill.
Okay, we can see your screen.
Can we start or we have to wait until 7 p.m.?
Well, actually, we were not waiting in the previous part of the session, so probably we could start.
Okay. Thank you, dear colleague. Let me represent our research in the area of the performance analysis of an organization. We study a dynamic simulation model which defines the team creation process. It's based on the social graph of the organization. We assume that the organization consists of several types of professionals, such as researchers, engineers, testers, and so on. And each project team must include at least one professional of each type. Another assumption that each node in the social graph has a degree of at least sigma. Let's start with the illustrative small example. Suppose we have a group of specialists with different skills or roles and the social graph of their connection. Here it is one of the possible team of 3 members. This red team can be formed due to lack of connections. Let's illustrate the simulation process of teams creation with the aid of non-deterministic function getTeams. Specific runs of this function will be denoted by the index R1, R2, etc. A team T is called completed if the skills of its members are sufficient to complete the project. Let's have a look at this interactive example. Let's consider a social graph G. Here, P is a set of professionals or employer. Alpha is a project profile. These 3 ones means that project need at least one specialist of each category, 1, 2, and 3. Let's simulate the whole process of team creation. Let the specialist P1 decide to initiate a new project. And now a team consists of the only member P1. And here it is the team profile. The specialist P1 randomly selects one of his friends, people whom he knows from this social graph. This person should has required skills and be available. So this specialist P4 has time available and his skill and has required skill, and P1 sends an invitation to P4 to join the team. Now our team has 2 members, and you can see how changed the profile. Specialist P1 doesn't send an invitation to P2 because his skill already exists in the team T1 profile. He sends an invitation to P5, and P5 accepts the invitation. So now we have a complete team T1. Then all other specialists try to create new teams. Let the specialist P6 decide to start a new project, and he does not send an invitation to P4 since P4 is already on the other team. So he sends an invitation to P2. P2 accepts it, but team T2 is incomplete, and there is no way to for the specialist P6 to invite someone else. So the invitation task transmitted to P3. To P2, but all friends of his are already on other team. So we couldn't manage to create the team T2, therefore this team is cancelled. Finally, the specialist P3 is trying to create a new team, but it's also impossible. So this team is also cancelled. So the only one complete team was created. Let's have a look at another possible models run. Let's start from the specialist P3, and let me skip a little bit these slides. I'm pretty sure that everything is understandable. So now we have one complete team T1, and specialist P2 started to create another team, and it's successful. So we have 2 teams, and this run is more successful than the previous. Here it is all possible runs, and let me remark that in general such kind of simulation process cannot create all complete teams. For example, have a look at the last picture with red circles. Team with members P3, 4, 5, and 7 is a complete team, but there is no model run that could create it. In this paper, we consider group members of 2 categories, just 2. Type 1 stand for researchers, and type B for engineers. where the cardinality of set A is n1 and the cardinality of set B is n2. G is undirected social graph. And we assume that for a successful project, one needs a team of one researcher and one engineer. And we assume that the social graph is bipartite, as far as we need one member of each category. It looks quite obvious. The utilization rate is defined as a fraction. The number of employees who are finally involved in project teams, it's not only one, over the whole number of all professionals of some organization. Let's see, research center of our university. So altogether, all researchers and engineer. And the greatest lower bound of the average utilization rate is found under the assumption, is based on the assumption that each node in social graph has a degree of at least sigma. Here it is, there are formulas for upper and lower bounds for the utilization rate in with this assumption. We implement a simulation procedure with the aid of Python, get random graph from number of members of two categories and sigma. That creates a random bipartite graph. It guarantees that every researcher is connected with no less than sigma engineers, and every engineer is connected with no less than sigma researchers. We run a lot of experiments. So T is a number of random graphs, and N is a number of simulation for each graph. And we calculate some characteristics of utilization rate. You can see the formula over there. And here it is graphics. Axis Y stand for utilization rate and axis X for the degree. And here it is all these calculated characteristics of utilization rates. And each graphic has a different number of vertices, so different number of the whole member of some organization. And here it is another graphics which shows another dependencies, utilization rate over there, over axis Y, and number of vertices, so number of organization members stand for axis X, and different degree of the graph. And we conclude from this work that typically random simulation results are far better than the worst possible bound established according to our theorem for tight lower bound. And for sigma 1, the average value of utilization rate is around 8%, much bigger than the theoretical minimum. And average utilization rate increases with sigma, which seems quite obvious. And graphs show then for sigma equal 3, where each employer knows at least 3 colleagues from the other category, the average utilization rate is almost certainly greater than 80%. So it means that, for example, for human resources manager of some organization, it isn't necessary to try to achieve the lower degree of social, bigger degree for social graph. And it's a third conclusion as well, and fourth. So therefore, for a high probability of getting on the team, it's enough for an engineer or researcher to have 3 contacts. And this means a simple practical recommendation I've already mentioned. And for further research, we want to consider more complex organization structure for some for different category of employee, and we maybe we have to include time, because in all our models in this paper and previous, we assume that all sending and receiving invitation take no time. So we are going to continue this kind of research. Thank you.
Thank you very much for your presentation. And colleagues, the floor is open for questions and comments. Okay, let me then clarify a thing I didn't quite understand from your presentation. So your modeling initially is based on some assumptions or propositions, for example, that a person who is trying to form a team sends invitations randomly to any person with relevant skills, and that they use only second level ties. They don't use friends of friends of friends, never, and other assumptions. And then as a result of your simulation, you get some structures. But I wonder if it is possible at all to run, to test this model, how well it corresponds to the observed teams and to some empirical ground truth data before passing to practical recommendations, because this at this stage, so far as I understand, it looks only as a very theoretical model.
Yes, you are right. This model is quite theoretical, but as far as we did a simulation, so we prove our theoretical results with simulation as well. Where is no. So that the lower bound for the utilization rate is greater or equal than 2 sigma, the degree of social graph over the whole number of members of all categories. And of course, you're right, we will continue this research in both ways, theoretical and practical.
Yeah, and I wonder if there are any data sets available that would allow to test models of team information. Like you have no team, something you have a data set that has no teams at some time point, and then they start forming, and you have information on who sent invitation to whom, and what the network structure is, and then you, in the end, you have some teams and their composition, and you can test, then you can test any theoretical model. But if such data sets do not exist,
in one of the previous work, we had common work with specialists from Gazprom Neft from St. Petersburg, and we created a model with the aid of any logic, and they provide us with some data of its research center.
Okay, interesting.
But here we just run the imitational model. This function, it's like imitational simulation function, which.
Okay, thank you, colleagues. Any other questions or comments? Well, if there are no more comments, let's pass to our last but not least presentation by Ilya Karpov, who will be presenting his work co-authored with Ekaterina Glaskova on bot detection using attribute graph embeddings and bipartite networks. Ilya, we can see your presentation and the floor is yours.
Hello, and we have modified our paper title. Now it sounds like detecting automatically managed accounts in online social networks, because our reviewers told us that this problem is a bit wider than bot detection. So, but the rest of the paper is as follows. I want to start from some demonstration to wake you up, because and show you that current bot accounts are much more complex than we are usually thinking. So right now, here you can see 3 profiles. This is the first guy, the second, and the third. And I'll give you just 20 seconds to think who of them may be a bot. Because all of them have well-filled profiles, all of them have messages, friends, activity, and when you're looking at them with a human eye, it's really difficult to find out who's who. And so for you to check your attention, the only real guy here is the person in the middle. All the rest of them are fake accounts created for some activities. So we can see that they're no longer empty, echo chamber, and with very few activities. They are much more sophisticated now. But of course, there are still many simple bots in online social network. And let's go to the formal definition. We can define a bot as an account created to generate profit for his owner by violating rules of the social network. And it is supposed to use automatic methods for these violation techniques. There are several existing approaches how to find those accounts, so I'll spend some time discussing them. The first one is manual annotation, when you just ask a human to label account as a bot or human account. So as we have seen at the previous slide, it's really not easy to find out what's going on just looking at their profile pages. The second strategy is that if we have some rule violation, that we can monitor suspended users lists, and suppose that these suspended accounts are bots that have done something wrong. This approach is pretty nice, but it has two problems. The first one is that we need to crawl all the necessary information for further classification before the account becomes suspended, and it's really not easy to do it quickly. The second problem is that not all guys deactivated by social networks were bots and some fraud activities. They just maybe rude with other people or used some or made some wrong posts on the wrong themes and so on. And the third strategy is some kind of creating honeypot accounts that attracts some kind of bots. So for example, very popular account that accumulates followers, or just an account with a certain topic. And it's obviously clear the problems of this strategy, because we will see only certain kind of bots with this honeypot strategy. All of these approaches are very nicely observed by Fred Marsater at his page. You can see the link below. And we have proposed another way to gather this information by doing account exchanges monitoring. So during our research, we have found something like almost 1,000 now sold accounts from 3 account exchanges by 20 sellers. And we have analyzed them. And so the benefits of this approach are, first of all, account isn't deleted already. It's the most of our accounts are still active and we can monitor their activity. Secondary, if these accounts are sold, they surely violate online social network rules, because social network restricts account purchase, and all activities that can be imagined for these accounts are not very good. So we have extended our approach to get more information on bots by using the second strategy from Marsater, by monitoring the suspended users lists and looking if there is some correlations between the suspended users and accounts that we have found during these exchanges monitoring. And another benefit of this approach is that we can see the price for a certain account, and it gives us some knowledge on how sophisticated this bot is. Because there are cheap accounts and they're most likely to be blocked very quickly, and there are very expensive accounts that are supposed to live forever. So here's a very simple correlation feed map, and generally, of course, we can see that the most important factor for this price is friends count, because some of these activities or some of these accounts can be used for some information propagation strategies. And in this case, friends count is very important. That makes them more expensive, but there are some other features also. So, and talking about the user profile, we can observe different parts of his profile, starting from his friend information. By the way, do you see my mouse? No, you don't. Okay, let's try to do it like this. Yeah, now you can. So we can observe his friends' information and analyze the network structure. We can watch his posts or reposts and analyze what topics he concerns, because usually those accounts are used for some fake news propagation, for some advertising purposes, and they usually concern some clearly defined topics. And of course, we can analyze some statistical features of the profile, age, country, education, because the more information you give on your fake account, the easier it is to determine that it is fake, because at some point someone will say, hey, he hasn't studied with me, I don't know him, and that's the problem with education, for example. And generally, we have divided these features on three categories. The purple one are some statistical features. The green one are features extracted from natural language processing, and the orange are network-based features. And there are quite plenty of works analyzing statistical features with different strategies, either with topic analysis. And recently we have observed 10 or more works doing some network analysis, but the problem with them is that they never combine network features with profile-based features. So our research was to find out if we can get better model with the combination of the network and statistical features. And this, of course, our further investigation will be on analyzing economic features. I'll speak about it later. So talking about static features, we have picked something like 30 features. Mostly of them are some flags. So do they have country? Do they have city? Do they have phone? Do they have friend? And so on. Some of them are categorical. For example, we tried to categorize universities, separated to several groups, and the number of photos were either categorized in several groups. So, and talking about the network features, at this work, we have analyzed only the friendship network structure. Of course, it gives some limitations because it's really useful to analyze groups, but so we don't have time to do all possible analysis. And we have observed two strategies for network analysis. The first one, I think I don't need to speak about this model in TVEC. It's very well-known model described by Kruger and Deskovitz 5 years ago. So that gives you some representation of your node and multidimensional network space by controlled random walk strategy. And if you're supposed to be at the given node and you previously were at the T node, so you have probabilities to move to your surroundings. I guess everyone knows this model. And our idea was to combine node-to-back model with features from these the static features of the profile and see how the classifier will deal with it. So the next one is a bit more complicated, and it's called entry-to-back, where you have your static features as a hidden layer. And so just given this picture, you can initialize your nodes as random coordinates in your attribute space, and then take into account static information to make nodes with the same features be closer to each other, something like this. And of course, this method supposes to use nodes homophily where similar nodes are closer to each other. So, and we have done something like 80 experiments using different variables for both algorithms, different activation functions, random walk parameters. So here are some results for node-to-back embedding and for the logistic regression classification. As I have shown earlier, we have divided our accounts into two groups, the technical one and the sophisticated ones. So talking about technical accounts, they are just cheap accounts and they're really easily detected with just statistical features. As for the sophisticated ones, so you have seen them at the very beginning of my talk. And we have evaluated several classifiers, and during this technical account detection task, we have found out that logistic regression shows us the best results. So we have used it for all the other experiments, and we have checked different strategies for detection of these technical and sophisticated accounts. And the surprising fact is that Tree2Vec shows best ever seen results on these simple dummy technical accounts, but very poor results on sophisticated one. So I think this may be caused by the fact that technical accounts have very poor information and their features can really be located on some single place of the multidimensional space, but it doesn't happen for the sophisticated accounts. As for the other models, so Node2Vec never shows best results, but the interesting fact is that combining Node2Vec and static features gives us the best result for the sophisticated accounts. So this was the model where we have just combined Node2Vec features with just one hot encoding of our categories. It's really difficult to compare this approach with existing ones because almost all data sets are either private and not published, or published, but they don't give us necessary information that can be used to reproduce our strategy. So that's why we have created our own data set with our salt bot accounts. And I have just placed some results from our colleagues from St. Petersburg and Moscow ISPRAN institution. And so, of course, here we have different data sets, so we can't be sure about these numbers, but it looks like using our data set, we have achieved very nice results. And finally, we have created this data set with anonymized data. Its size is something like 10 gigabytes now, and you can find them at our GitHub repository. We have evaluated more than 80 network embedding models, and you can find all the evaluation at the repository and check what's going on there. As far as the data that is used for the evaluation. And we have compared several classifiers with static features and network embeddings and their concatenation. So thank you very much. And I guess I don't have time for further research. I'll just ask for questions.
Yeah, I'd like to remind that in track A, a guest lecture is now, or keynote speech is now starting, but everybody who wants to ask any questions is welcome to stay here and ask questions.
I guess this is the problem of online conferences. Everyone is doing something else.
I guess people are just a bit tired by 7:30 p.m. But this doesn't make your presentation less valuable. I was writing down, I was making the notes. I don't have any questions so far, but I was making the notes for myself. your presentation.
So if there are no questions, I can just say a few words about further research, because the nice thing about the strategy with bot collection is that there are not only network information on the accounts, but there are also posts, and we can analyze what kind of information they spread, and analyze exactly these posts and who else posted them, because we already know that these guys are bad ones, and we can see who else posts this information or makes some reposts. And this is the good point to start working with text embeddings and see how this can affect the resulting classifier. So the second problem is that many accounts have their friends hide it, and it's difficult to get the network embeddings. So I really think that group analysis information can give boosting to this problem. And finally, it looks important to try some temporal network analysis, because those guys visit the network simultaneously or one by one, and maybe we can pick some of the strategies to make the results in classifier better. So these are main ideas for further investigation.
Okay, I got one question about your data set. Do you have not only bots but also real live accounts there?
Yeah, of course. So our final data set consists of something like 1,000 verified bots, 42,000 hypothetical bots. They were suspended. I could suppose they were suspended because they were bad ones. And something like 300,000 users that surround them, because we were generating node embeddings at the connected component, and we tried to get connections as far as possible to get the largest connected component for our node training. So we took our bots, their friends and friends of friends, and this gave us something like 300,000 profiles, and the next jump caused us to collect 20 million accounts. We decided that it's too much for us and stopped at the 300,000. So our collection is imbalanced, and it has 300,000 real users and something like 40,000 bot accounts.
Well, my question was, how do you know that those are not bots? In order to know that an account is not bot, you have to annotate it. Otherwise,
yeah, that's the problem. So you're right. Maybe we know not all bots that we have observed from the stock exchanges, and some of our real accounts are not so real. That's the real problem with this research. So I guess we have nothing to deal with it, just to collect more data and see how our classifier will look at different analytical curves, the stableness one. Yeah, but this is the problem. You're right.
Okay, thank you. So, dear colleagues, those who have survived, thank you very much for your attention. Our session is over, and all of you are welcome to the evening keynote speech.
Thank you very much, Alessia, for chairing this session. Thank you very much to all the speakers, and those who would like to join the invited talk in Track A in Zoom, please follow the link that you probably already used.
Yeah, thank you, Dmitry. And bye-bye, everybody.
Bye-bye, Alessia. Bye-bye all.